네, 잠시 안내 말씀드리겠습니다. 잠시 후 2시 20분부터 글로벌 오픈 이노베이션 포럼이 시작될 예정입니다. 모든 참가자분들께서는 자리에 착석을 부탁드리며 원활한 행사 진행을 위해 소지하신 휴대폰 및 전자기기는 전원을 꺼주시거나 무음으로 전환을 부탁드리겠습니다. 또한 본 행사는 동시통역 서비스를 제공하고 있습니다. 한국어는 3번, 영어는 4번, 그리고 일본어는 5번입니다. Today's event provides simultaneous interpretation service, so please tune to channel number 4 for English and channel number 5 for Japanese. Thank you very much. 네, 잠시 안내 말씀드리겠습니다. 저희 오늘 본 포럼에 앞서서 개회식이 진행이 됐는데요. 저희 조금 죄송합니다. 양해를 부탁드리겠습니다. 본 포럼은 잠시 후인 2시 30분부터 시작하도록 하겠습니다. 너그러이 양해해 주신 모든 분들께 감사의 말씀을 전하며 본 행사는 동시통역 서비스를 제공하고 있습니다. 아직 통역 수신기를 가지고 오지 못하셨다면요, 저희 행사장 입구에서 동시통역기를 가지고 오셔서 채널 3번은 한국어, 영어는 4번, 일본어는 5번인 점 안내 드리도록 하겠습니다. Today's event provides simultaneous interpretation service, so please tune to channel number 4 English and channel number 5 for Japanese. Thank you very much. And also today's forum will begin at 2:30. Thank you for your cooperation. 네, 이 본격적인 행사 시작에 앞서 잠시 안내 말씀드리겠습니다. 오늘 행사는 코엑스 2층 아셈볼룸에서 개최가 되고 있는데요. 조금 있으면 스크린에 지금 계신 행사장 비상 대피로를 확인하실 수가 있습니다. 네, 지금 스크린에 있는 비상 대피로를 꼭 확인해 주시길 모든 분들께 부탁드리겠습니다. 또한 이 행사가 진행되는 동안 혹시라도 이 긴급하게 도움이 필요하실 경우 행사장 입구 쪽에 있는 이 한국산업기술진흥원 등 이 행사 준비 관계자분들께 말씀을 부탁드리도록 하겠습니다. 여러분들 모든 분들께서 마지막까지 안전하고 이 편안한 행사를 함께 하실 수 있도록 동참해 주시면 대단히 감사드리겠습니다. 네, 오늘 많은 분들께서 함께해 주셨는데요. 저희 본 행사를 곧 시작하도록 하겠습니다. 아직 착석하지 않으신 분들께서는 자리에 착석을 부탁드리며 아직 동시통역 수신기를 착용하지 않으신 분들께서는 한국어는 3번, 영어는 4번, 일본어는 5번인 점 안내 말씀드리겠습니다. Today's event provides simultaneous interpretation service, so please tune to channel number 4 for English, channel number 5 for Japanese, and the forum will begin shortly. 네, 여러분 혹시 준비되셨으면 지금 바로 포럼을 시작해도 괜찮을까요? 네, 감사합니다. 네, 여러분 그럼 오늘 포럼을 시작하도록 하겠습니다. 네, 오늘 여러분 이 무더웠던 여름이 지나고 풍요의 계절 가을이 다가왔습니다. 이 선선한 바람이 기분 좋은 9월의 마지막 주, 이 바쁘신 와중에도 불구하고 이 대한민국 기술사업 혁신을 위해서 글로벌 오픈 이노베이션 포럼에 이 귀한 발걸음 해주신 모든 분들 그리고 온라인으로 함께 해주시는 모든 분들께 진심으로 감사의 말씀을 전합니다. 네, 여러분 인사드리겠습니다. 저는 오늘 포럼 진행을 맡은 아나운서 김선우입니다. 여러분 반갑습니다. 네, 감사합니다. 네, 오늘 진행되는 글로벌 오픈 이노베이션 포럼은 이 대한민국 기술사업화대전에서 처음으로 개최되는 행사로 국내 기술 사업화 현황뿐만 아닌 이 해외 주요 국가별 기술 거래 및 사업화 현황과 이 사례를 공유하고 이 발전 방향을 모색하는 소중한 자리로 마련이 되었습니다. 오늘 여러분들의 이 고견을 함께 나누며 더욱 발전할 수 있도록 여러분 끝까지 힘을 실어주시면 대단히 감사하겠습니다. 네, 그럼 본 행사를 시작하기에 앞서 오늘 준비한 행사 진행 순서를 안내드리도록 하겠습니다. 네, 오늘 포럼 1부에서는 해외 기술 사업화 현황에 대한 발표가 진행이 되며 이후 2부에서는 국내 기술 거래 현황 발표 후 이 패널 토론이 진행이 될 예정입니다. 여러분 끝까지 함께해 주시면 감사하겠습니다. 네, 그럼 지금부터 주제 발표 시간을 시작하도록 하겠습니다. 네, 오늘은 총 4분의 해외 전문가분들을 모시고 해외 기술 사업화 현황에 대해서 들어보도록 하겠습니다. 네, 오늘 포럼 1부의 첫 번째 주제 발표는 글로벌 지역 관점에서 기술 이전 역량 강화라는 주제로 ATTP 의장이신 알윈 웡님께서 발표해 주시겠습니다. 여러분 의장님을 무대로 모시겠습니다. 따뜻한 박수로 환영해 주십시오. Mr. Arwin Wing, please come up the podium.
Good afternoon, distinguished guests, fellow participants, ladies and gentlemen, and fellow speakers. It is indeed my honor to be able to come to this particular event held in Seoul, and a big topic for a relatively small number of people who dedicated their career and profession towards achieving the entire open innovation across borders. My topic, rather than giving you a country report, is to be more on the aspect of a global movements towards open innovation across the borders, across nations, of course at the request of the organizer to give a little bit of illustrations based on a country. And being an ethnic Chinese, having spent my career in Hong Kong, and it is very natural for me to talk about Hong Kong. No, it's only a small city. To talk about China as a competitor and also as a very formidable national, international power moving towards that agenda very much similar to many other parts of the world. And maybe you can also draw the comparison. And also, on behalf of the Alliance of Technology Transfer Professionals, with Korean Autumn Associations of University Technology Managers, we represent 16 member associations from across the world to help in capacity building of local ecosystems in training and recognizing technology transfer professionals. And I'll touch a little bit on that. And I guess everybody who is in the room would be very familiar with the triple helix system, the government, the industry, and academia. And of course, you have the dynamics, and that it actually differs from country to country. I was just talking to my German colleagues next to me and saying that Korea has a very high distance hierarchy in terms of cultural difference from hierarchical cultures, so that it is very much as an honor for the deputy minister or people high in power to hand out certificates, and people pay very, very dear attention to that. And I guess it would also happen in other Northeast Asian countries like Japan and China. And whereas, in Americas, and people would just go to the bar and all that. And so within that triple helix, you have interaction, collaboration, and challenges, because there are stakes, opportunities, risks, and rewards involved. And within each country, you have the policy and cultural influence on TT practices. And a lot of the practitioners have to look up to the government for the policies, funding, because they redistribute and manage resources as taxpayers' money. And of course, as nations, we do look after our national interests, as the Deputy Minister just now said, on the key areas of interest in terms of technological innovation and development. And of course, we cannot spare it in this particular reality, world of reality, international relations, and geopolitics. So I will not go into the 101 of technology transfer and talking about the details issues along the TT value chain. Of course, the government need to come out with consistent policies for all sectors, both private, public, and academia, to look into our diverse interests in terms of governance, and if the industries are more capable in absorbing TRL level, lower TRL level technologies, it would be easier for them to work with the government and the academia to commercialize or put technology into use. Of course, a lot of the economic growth and innovation thereof is from the small and medium enterprises, which we as laymen and also as governments should not ignore. How can we address that mid-range TRL 4 to 8 that is always and often missing from laboratories to production? Different countries, different economic ecosystems have different ways to addressing that. And as academics and scholars and professionals, we always try to measure and try to justify how well we are doing or how bad others are not doing. And that comes into metrics. And of course, if you come in from a government sector, the metrics would be different from academia and also from the industry. And how do you address that different agenda? It is always interesting as we propel and move along towards what we were trying to say, a win-win world whereby we can achieve synergy through stuff like open innovation. But in reality, who gets what is always a quid pro quo kind of thing. Then you have to consider risk and reward. Who gets what? Of course, the ideal situation is government to bear all the risk, and then the commercial guys get all the rewards. And where the academics would work for free, or with a lot of research money, but that is not sustainable. So as we evolved, what kind of things that we need to address, it is bound to be something that has to come down from a national policies and effects on the player behavior, especially for countries with a more structured kind of policy, rather than, if you come in from the American perspective, then you have the Bayh-Dole Act, and then the market pretty much would handle the rest. Of course, give and take, then you have very, very great funders like the Department of Defense, Department of Energy, and then NIH. But then the government would probably look into the tax incentives, funding for academics doing translational research and commercializations, and inventor benefit policies. And the norm for international attribution of commercialization process is the professors would get 1/3. But in certain places, then I'm going to illustrate, it is not the case. And of course, different motivations with the same organizations. For certain universities, now that the name of MIT is mentioned, you give the policy and the academics would do the rest. In China, for example, the better universities, and then if you can come to the rank of academicians, you can have a team of more than 200, 300 people. So you can do scholarly research, get publications in Nature, and do commercialization, consultancy, whatever, as a mini educational enterprise. So each to his right, but again, at the end of the day, is risk and reward. And I guess, for individuals, what you consider is most valuable to you. On this particular section is after all the studies, and we do have some sort of global agreement on the big picture as to what kind of metrics would work for what kind of, in terms of measure the success of knowledge transfer, technology transfer, but there is no one size that would fit all. I guess the latest publication that is mostly referenced to is the knowledge transfer metrics commissioned by the European Commission, published, I think this is a 2020 paper by many of my known colleagues, and who came out with something like 60, 70 pages of report. And pretty much it tells you the key things, the basics, where you have the licensing, the patent, the spin-off, the entrepreneurship activities, etc. And based on that, we're trying to, as far as ATTP is concerned, trying to actually collect metrics from different countries and policies from the world, and to see what are the actual implications. But there are subtle differences. Let's say if I would quote an example from my colleague who have been working with me under the autumn subcommittee looking after the Asians' interest. If you quote the Japan, for example, the number of spin-off companies out of universities compared to the Chinese spin-off companies, you're talking about 100 to maybe about 300,000 a year. So is Japan anywhere lacking? No. It was the number 2 GDP, highest GDP per capita, and also the total capita in the world, if I remember correctly, is still number 3. So the activities and the policies has a lot to do with how they would shape the different kind of outcomes and the impacts. And this is something we need to look into as practitioners on innovation and entrepreneurship policies, and also the licensing, and also the, in terms of the actual practice. To my concern, actually, I was also talking with another colleague just now, it is how all of these would eventually impact and help the small and medium enterprises. Korea is doing pretty well in terms of international ranking, but how about the countries who are still on the list of OECD countries who are, let's say, outside of the 100 rank, and they are trying to compete and to become more innovative just to survive. So, I mean, there would be organization of agencies and intermediaries, and we have the president of, I cannot remember the name, who just spoke, and she put in a lot of efforts in coordinating Koreans' work. And then we have government agencies who's trying to collect data and shape policies. But metrics and KPIs are not necessarily convergent, even within the universities. If you talk to a department head who is pressured to maintain a certain ranking in this publications of the department, they would not talk about technology transfer. Publications is either publish or perish. And how do you motivate tenure professors to keep productive? And this is another issue. And then you have the deans who would be aspired to become VPs and the top management, and who would be thinking about something else. So even within a university, there would be different kind of metrics measuring different kind of activities, and they do not necessarily align. More so, they would tend to conflict. I guess, I'll save that for another time. That is pretty much the opening. If you'll be looking into open innovation, who drives what? In the world of resources, give and take, I guess using the resources model for anybody who's come out to be a player of open innovation, and at the end of the day, there's the risk reward. And if you're really smart, you can create synergy. And in all these things, it involves policies, regulations, and people who are sort of like a catalyst work between them. And I'll then would go into the Chinese innovation ecosystem. If I'm spending too much time, please remind me. I forgot to set my alarm clock. So I promised that I would stay within my 25 minutes, and I forgot what time I started, but I think it was just about 6 minutes ago. For the Chinese innovation ecosystem, it seems I don't need to repeat, because the Deputy Minister of Korea just mentioned about similar things in the opening section. Everybody is competing on these national forefronts in terms of technology innovations, so that they can become more dependent and having more say into the technology frontier at the end of the applications. By that, we're talking about the Chinese would always come in. I'm talking about the Chinese government would always come out with something said, that we need to put in resources to address technological bottlenecks. Developing new industry verticals in terms of new materials, semicon, telecom, computing, biotech, AI, digital economy, data security, green energy, and EV, and more. And by putting in a lot of resources into these areas, some would succeed, some would fail. The conversion rate is not necessarily high compared to MIT, Stanford, and I can go on and on. But the impact or the result is they come out with, for whatever that was successful, they come up with a lot of overcapacity, and they start exporting. And that would create some sort of impact, even though it is good thing in the country that is good technology commercialization, but for the rest of the world, it is a problem because they're exporting cheap stuff. And why is it cheap? Because it is government policy, and somehow there must be tax exemptions and encouragement for them to export with subsidies. So the Europeans got excited, and the Chinese and the Americans get upset because this is not fair competition. And in fact, it is not. So how do we tackle that open innovation? I don't have an answer. And fortunately, I don't get invited here to talk about answers. I just want to share the issues that is here today, that are here today, and that will be here tomorrow and future. And for China, I guess I can tell you in terms of policy support, they have many joint R&D programs in terms of government with the local industries, both large and small, with local universities, and they have technology commercialization funding that the government would take almost all the risk, with no risk to the academics to develop something that may or may not be useful to the industry, as long as you are within that technologically verticals that the government would pay a lot of attention and resources for. Conversion rate is slow, but then it just keep going. Tax concession schemes is, if you're successful in commercializing certain things, you get tax exceptions and here and there and all that. And I guess you get a good rebate or tax refund for being able to export some of those stuff. So if you have a better names of the EV manufacturers like BYD, and they are doing horizontal and vertical expansions. They're building their container liners, they're building the factories out in Europe by trying to sort of capture that kind of skill. But for the minor EV manufacturers, many were elite manufacturers like some of those BMW elites who got into the earlier waves of the EV ventures, that they all died out. And this is still a fierce competition within China themselves that is almost like a cutthroat business. And only, I think, the larger 1, 2, 3, 4, 5 maybe would continue to win. Huawei was making EVs, and it just sold its brand to its own OEM manufacturers. And I guess people outside of China would not pay so much attention to that. But this is how the competition goes. High-tech zones, science parks, accelerators is supposed to support new entrepreneur and spin-offs from universities. The casualty rate is high, and the property developers would always try to come in and to work with the government to make a quick buck. And this is what the economy is. For R&D infrastructures that we are more familiar with, and you have national laboratories being established, like the equivalent of the jet propulsion laboratories in California. State Key Labs. State Key Labs is based on universities. Let's say, if I would quote Dr. Min's expertise back then, and in Kyushu, the university, and in physics and nuclear engineering, that kind of stuff. University government research institutes, I would not go into that because there's so many of them. And from straightly a shop talk, as a technology transfer practitioner, what they would try to do to bridge the TRL gap, as I mentioned, that is missing from 4 to 8. They do academic industry collaboration, and something that you could pay attention to for China is actually when they do the inventor benefits. 1 minute? Okay. Thank you for reminding me. Is they give 70% at least to the professors, whereby the norm is 1/3. And capacity building and process management, they now look into the human resource aspect of it and saying that we need to do technology transfer professionals to train them and to give them professional accolades so that they can become a career practitioners. So by 2022, there is a formal recognition of technology transfer managers as professions. And the result, over 5 years, you see the number of contracts went up 50%. The amount of contracts went up 100%. The contract amount may not get totally fulfilled, but this is something that you can see, at least from the nominal figures. And I guess for people who would be able to get the slice at the end of the day, this is what the contribution of academics in universities that are being able to do in China. This is the latest figures that I'm able to get. And you can see that this is about 1/3 or 1/4 of the numbers that I've mentioned just now. And the center, lower center, is actually on licensing. And on the right side, is actually on collaborative research and contract research, and look at the scale. And of course, then I've mentioned about geopolitics, the barriers about open innovation, IP protection, and different laws, and different government policies to different things. And if you look into the more acceptable metrics universally by WIPO, Korea is ranked number 12 as of 2022. China is close. But if you look at the change, the curve is from Korea is actually So Korea is doing pretty good in terms of GII metrics. And we will save that for another time. For ATTP, I've mentioned a little bit about that in the beginning. And Cotton was the 15th member, with KiwiNet from New Zealand being the 16th. And we are actively helping other economies to build up their human resource capacity for accrediting technology transfer professionals. With such attributes, and this is what we are looking for, and I certainly believe that this is a global movement, but with local practice, because only local economies and players know very well as to what they need to do locally to breed their own people to fulfill their own mission. And those are the career options copy right out of Autumn, the American University of Technology Managers. Now it's changed its name back to just AUTM. And this is where you, in building your own ecosystem, will try to groom technology transfer practitioners so that they can have their career input to achieve the technology transfer output. So with that note, thank you very much, and I'll pass the time back to the coordinator. Thank you.
Thank you very much. You're very much informative presentation. 여러분 다시 한번 큰 박수 부탁드리겠습니다. 네, 고맙습니다. 이 알윈 웡 ATTP 의장님께서는 이 발표를 통해서 이 글로벌과 지역 관점에서 기술 이전 역량을 강화하기 위한 이 정책 및 세부 내용에 대해서 발표를 해주셨습니다. 다시 한번 감사의 말씀 드리겠습니다. 네, 이어서 다음 발표를 이어가기 전 안내 말씀드리도록 하겠습니다. 오늘 준비된 모든 발표는 각 발표당 25분씩 발표 시간을 드리는 점 안내 말씀드리겠습니다. Today's presentation, each presenter has 25 minutes for maximum. So please remember this. Thank you very much. 네, 그럼 이어서 다음 주제 발표를 이어가도록 하겠습니다. 다음 주제 발표는 슈타인바이스 유로파 센터 CEO이신 닥터 조나단 로에플러님께서 유럽 중소 중견 기업의 개방형 혁신 과제라는 주제로 발표를 해주시겠습니다. 여러분 큰 박수로 환영해 주십시오. Dr. Jonathan Loepler, please come up the podium.
Yes, ladies and gentlemen, I have my with me, so the time I try to to keep it. Yes, distinguished representative of the Ministry of University Research Organization, it's for me a great pleasure to be here today. Actually, I'm a French guy presenting a German organization in Korea. So this is something very international, and I'm very honored to be here today. And thank you very much for the invitation. It's my first time in Korea. In the next 20-25 minutes, I would like to give you an overview how the thematic of open innovation is approached in Europe, mainly in Germany, actually. And I will give you some concrete example of projects we are doing with small and medium-sized enterprises, because these are our focus group to support small and medium-sized companies. But before getting in the heart of the matter, a few remarks at the beginning. First remarks, I would say knowledge has some similarities with water. Why this? I'm sorry, I'm a chemist, and I would like to introduce a little bit about knowledge transfer and also open innovation in a comparison with water. Why? Universities, research organizations are knowledge creation hub. You have there the knowledge created. And a source of solution for complex products, complex problems. And I'm still fascinated actually by all the creation and the knowledge created in universities. Water is also a fascinating liquid. Why? It's on Earth about 70%. Small quantities, drops, helps us to survive. Plants, ourselves, also animals. Also, like water, knowledge is essential, I would say, for our life and for our society. 75% of our body is made out of water, and at least, let's say, 80% of our brain is out of knowledge. I know not always useful, but still we have it. This was just a smiley, you would agree. And last remarks, rain is coming from the clouds, and now more and more knowledge is also coming from the clouds, from the internet, I would say. But to be more serious, the cycle of water is incredible. Water comes from clouds in small drops and is distributed randomly to the Earth. Part is taken by plants, by animals, by humans to survive, but some of the water is flowing, moving below the Earth. Water drops go through caves and rivers and are taking minerals, are taking elements, essential elements with them. And then it goes to rivers, and it gathers to bigger rivers like the Han River you have here in Seoul. And you know, all the big cities, if you look, mainly all the big cities are near to a river, because it's so important to have it. And I would say also for knowledge. The big rivers go to the ocean. Water integrates oxygen for fishes, but also integrates CO2. So these are fantastic properties. But the secret of water, as a chemist, I would say, are this. Actually, normal-wise, water should be gas. It shouldn't be a liquid at room temperature. Why is that? Actually, the boiling point is 100 degrees, but without the small hydrogen bonds, it should be minus 62 degrees. And that's quite interesting, because these small hydrogen bonds helps that water is still a liquid. I will stop the scientific explanation here, but keep in mind these weak hydrogen bonds. This gives special properties to water, and I'm convinced that these bonds give also special properties to knowledge if we can create them in open innovation projects. Open innovation and knowledge transfer is actually building these bridges, these small hydrogen bonds between person, between organization, and it's a key factor, I'm convinced, to do open innovation. University plays an essential role in this process. Knowledge must circulate, knowledge must be shared like water. So I would like to give you two perspectives in my presentation. First perspective will be on ecosystems. We heard about it, how it is organized at national, European level, regional level. But most important is also the second perspective, which is on projects, doing concrete projects with small and medium-sized companies. So the work of our organization, Steinbeis, is actually at the level of individual companies, the small and medium-sized companies, and we try to build these hydrogen bonds between the actors. We are running about 100 projects every year, and I will give you some examples. We heard about it already. Our society is changing a lot in all these different domains. Digitalization, industry 5.0 already, but also climate, energy, agriculture, bioeconomy, health, culture, creativity, and transformation within our society. You probably heard that there was a G20 meeting in Brazil, in Manaus, and I was totally surprised that they had said something about open innovation. So the G20 agree about open innovation strategy and recommendation, and all the ministers said that open innovation should be organized for a just and sustainable development. And they emphasize that open innovation are essential tools for addressing global challenges and actually our societal challenges. And this is why I would give you some example later. But just some history about Steinbeis. Steinbeis is an old foundation. Actually, it was already created in the 19th century, and then coming back 40 years ago. And Ferdinand von Steinbeis, a German entrepreneur at that time, he was a pioneer. He was looking for new technology in Holland and bring the machine in Germany and show how it works. And he said, you have to focus on innovation, that's right, on new technology, but also on people. And I think the hydrogen bonds can only be actually created between people. Without the people, it's not possible to create open innovation project, in my sense. People permit to create this and create these hydrogen bonds. Our foundation is actually a network of more than 1,100 enterprises, partners worldwide, and the revenue is around 160 million euro. And what is important about this revenue? Actually, 80% is private revenue, 20% is only public funding. And this is, I would say, and we can discuss it later, it's one way to measure open innovation and commercialization to see how much private revenue is coming from the industry in these projects. We have about 5,000 people working in the network and more than 600 professors. And these professors, they are at the beginning of the knowledge. They are bringing a solution, but they need the capacity to talk with the company, to talk actually with the receiver. We heard about absorbance of knowledge from Dr. Arvin Rong. This is an important topic, and this is what we are doing. And we also have a good partner here, ED Research in Korea, and we are very pleased to work with them and to cooperate with them on technology transfer projects. Thank you very much. So, as I said, we are concentrating on solving challenges for company. So we start with company side, with a market, and we try to do some research and development project with experts, with professors. We do also a lot of consulting, and we do some training. So coming back to the initial say, we understand ourselves as enabler. So we are not at the university side, we are not at the company side, we are in between, enabling this growing phase and building these bridges. So our organization, Steinbeis Europazentrum, in the network, we are about 100 persons doing international open innovation project. We have more than 15 different nationalities, and we are quite interdisciplinary. And you see also at our level, more than 60% of our partners are small and medium-sized companies, are enterprises. Of course, we are working with university, research institute, with cluster and networks, and with public stakeholders. But the focus is really on the industry. And I would like to give you some small example of project in our region. So it can be on electrical motor. So this small company develop a new electric motors, lightweight, much more efficient. We have a small company on CO2, neutral synthetic fuels, and product for everyone. So very small company growing more and more. We have also problem of rare earth material. So how to use a rare earth material which you have already in your computer, in your smartphones. Is it possible to get it back, actually to create new magnets? Because with all the magnets we will need to have all electrical motors and all electronic device, it's a real problem to get enough rare earth. We have a nice project as a spin-off of a research organization on hydrogen compression for heavy transport. And last but not least, also a bigger company which is on the quality of air. And here we have done a European project. So this just gives you some example of concrete project we are supporting during 1, 2, 3 years. So it's not, I would say, only 3 months. It needs time. And this is very important that you have organization accompanying these different companies. So, you know, this is a figure from the European Commission. European Commission has a big funding program. And you can see the different technology branches and the link between these branches. And you need people not only from one aspect. You know that innovation is coming from interfaces from different branches. And this is a key element, how to get different branches, different sectors working also together. I was 10 years ago in Croatia, and I met an old professor, and he was technology transfer office manager, and he told me, you know what, it's nearly impossible to get scientists and business people from company working together. They are just separating like water and oil. I was surprised, of course, but I like this image because it's not natural for scientists, for researchers, or natural for companies to work together. That's a fact. But as a chemist, I said, if you bring energy in it, you can have emulsion. And you can have a very, very nice picture. If you bring them together, you have more interfaces. And this is actually what we would like to do, to bring energy and to have interfaces to collaborate. And how to do that is to be aware, and we heard about it, that here, just 2 minutes to explain it, on the left side, you have the different types of technology readiness level, if you want. So basic research, research proof, development phase. And you see on the right side, the type of small and medium-sized company. And actually, in a natural way, we say in Germany, only 1 or 2% of company can absorb this knowledge coming from university. 1 or 2%. Then you have the early followers, and then you have the late followers, but the total of company having the capacity to absorb this are a maximum of 15 to 20%, and that's not a lot. And how to get them? That's a very difficult aspect. How to get them to absorb the knowledge. And if you go with a scientist which coming from basic research, I was at the Max Planck Institute doing my PhD, I know their basic research is so important, but when I talk with the company, he will not really understand what I was doing. And how to manage this is a real challenge of open innovation. So first of all, we try to identify which sort of company we have. Is it a pioneer? If you have a spin-off coming from a university, you have engineers, you have scientists in this company. They can absorb the knowledge, that's right. But it's a very small amount of people. if you have engineer R&D department in company, it's possible, but it's not a normal way. And this, we have to be aware of it and how to deal with these different types. So actually, we try to come from the main objective of the company. So main objective of the company is business development, so develop new products with new functionality, and having new clients and new market. And we say to them, okay, if you collaborate with research organization, you can have new functionality in your product, you can develop new products, and then you can have new clients. And we do it at European level, at least, so you have contacts for market, to sell in other markets. This is one argument we have. Internally, they sometimes tell us, okay, we have some quality problem, we have some production and cost problems. It's not, they're always saying we are the best, that's normal. We sell the best products. But if you ask, they say, okay, we would like to improve this or that, or we would like to reduce the costs. Also there, we can have help of university knowledge to achieve this through artificial intelligence in the industry, for example, in production, we have some projects. So what I wanted to say is just give them the link between their objective of the company and the offer they can get from university. How we do it step by step, and this will be the last 3 steps I would like to present. Actually, we start with innovation management, so we try to find for them a right strategy and partner. We help them here to get the right partnership, so to look if it makes sense for them and with whom they should do that. And we look for so-called missing links, actually what they need in their development. Sometimes the missing links are quite difficult to get, and we are a neutral partner. That's important in our job. Actually, we help both sides. We are not on one side or the other side. We try to be on both sides, and we try to help because in such projects, you have times where it becomes difficult for IP reason, for different type of reason, project management reason, and then we help them to have the strategic partnership and the strategic approach. We help them to get funding. Funding is also good in some different solutions. So here one example of a company, 100 people, welding, so real industry. We follow them for more than 20 years, and they get 30 million euro to make their development. So it's a concrete way for them to get a step further. And now I come to the European perspective, just to give you some figures. Actually, it's possible, there are more than nearly 100 billion euro from the Horizon Europe program to get some project like this. And Korea can participate. And actually, that's a very important thing. You hear it from the Deputy Minister already. Korea can participate to this program with Europe. So that's very interesting. About 50 million is for company and competitiveness of company, and about 13 billion actually for startups and innovative SMEs. So that's a good opportunity to collaborate together. Here again, it will start in January 2025. Korea can be an associated country and also participate to that. Okay, I still have 5 minutes, thank you. Here, these figures to show you, actually, Europe, with help of this program, of this funding program, tried to build different ecosystems. In different domains, I will not go in details, but remember these figures with all the link between the different technology program. The objective is to link ecosystems. If photonics people are working with photonics people, you will get new knowledge on photonics, but not innovation, not application. If you have photonics with health people, here you can have applied innovation for the society. And this is a big challenge, actually, we have, and what the European Commission would like to achieve with different steps. They want to connect the ecosystems. So there is a new innovation agenda of the European Commission with innovation valleys, with different initiatives to connect the different ecosystems. Because in Europe, they are good organized for them, but the connection between the different ecosystems is not yet here. And last but not least, where we help, as I said, is to get contact on international markets. So it would be very nice also to help them to get contacts for our company in Korea, if possible, or the other way around, for Korean companies in Europe or in Germany. I'm at the end of my presentation. I just would like to give one quote on that. Benjamin Franklin said, an investment, and there is another forum on investment, but actually an investment in knowledge pays the best interest. And I'm convinced about that. Thank you very much.
Thank you very much. It was just such a meaningful presentation. 여러분 큰 박수 다시 한번 부탁드리겠습니다. 네, 감사합니다. 이 슈타인바이스 유로파 센터의 CEO님께서는요, 이번 발표를 통해서 이 유럽의 중소, 중견 기업의 이 개방형 혁신 과제에 대해서 굉장히 디테일한 내용을 발표해 주셨습니다. 다시 한번 감사의 말씀 드리겠습니다. 네, 다음 발표를 이어가도록 하겠습니다. 다음 발표는 토다이 티에로의 대표이사이신 닥터 케이코 혼다님께서 동경대 티에로의 기술 사업화 현황 및 미래에 대해서 발표해 주시겠습니다. 여러분 큰 박수로 환영해 주십시오.
はい、私すいません、今日こちらに来るまで英語でスピーチしようってずっと思いながら、ずっとこう飛行機の中もずっとこう原稿を読んでたんですけど、日本語でいいよって言われたので、すいません、日本語でスピーチさせていただきます。25分っていう時間も、はい、きっちりこれで日本語で守っていきたいなというふうに思っています。よろしくお願いいたします。まずはじめにこのようなフォーラムお招きいただきましたこと、本当にありがとうございます。で皆さんのそういうスピーカーの方、お越しいただいた方々に日本の状況であったり、東京大学 TLO の活動を知っていただけるっていうのはとても光栄に感じておりますし、ぜひこの後皆さんにいろんなお知恵をいただいて帰りたいなというふうに思っておりますので、ぜひよろしくお願いいたします。でまず私の話を始める前に、はい、少し東京大学 TLO の紹介と私自身の紹介をさせていただければと思います。東京大学 TLO は、東京大学TLO ですけれども、本当に日本の、産学連携の政策に沿って、設立して発展してきていると言えると思います。でまずはじめに1998年に日本でいうところの TLO 法案っていうのが成立しております。でその時に、まさに TLO を作ろうって日本の中でそれが必要だっていうことでこの法律ができたわけなんですけれども、その年にまさにこの東京大学 TLO っていうのが設立しております。でその後日本の中では1999年に日本のバイドール法っていうのが成立しまして、で、2004年に国立大学が法人化するっていうような年を迎えてます。でそれまで私たち1998年から技術移転を行っていたんですけれども、その時には個人の研究者に、が保有している知的財産、それを本当に限られた数の知的財産をの技術移転をやっていました。で、そういう活動をやっていたということを、東京大学がそれを、知って ぜひそういうノウハウを持っているのであればということで、2004年に東京大学と技術移転に関する契約を締結して、2004年からは東京大学のすべての発明を扱うような組織に発展しております。でその後、2009年に東京大学の 100% の子会社になるということで連携が密になっているっていうような経緯でございます。で私自身はですね、この2001年に法人化する前からこの会社にジョインして技術移転やっておりました。バックグラウンドが、研究者をやっていたということもありますし、パテントエージェントですね、日本でいうところのその資格を持っているっていったところで、その2つをうまくてこにしながら何かこの事業に役立てたらいいなということで2001年にジョインしてます。でその後、23年ですね、2023年にちょっと左、皆さんから見ると左ですねに写真がありますけれども、前社長山本ATTP の方々はタカでの愛称でよく知られているかと思うんですけれども、彼からプレジデントのバトンを本当に紙で作ったプレジデントって書いたバトンを渡されまして、それから社長に就任しております。今日お話ししようと思っていることは、日本の産学連携の現状をお話しするのと、東京大学 TLO のアクティビティについてご紹介していきたいと思います。でまずはじめに簡単にオーバービューっていったところで日本の産学連携の状況をご紹介したいとは思うんですけれども、日本は、日本の国立大学っていうのは2004年に先ほどご説明した通り国立大学の法人化をしています。で、もちろん政府資金以外にもやはり外部資金、民間企業からの外部資金の調達っていうことが必要になっている状況です。でその中でどういう資金が調達できているか、ある種これ文科省のデータ、文部科学省のデータなんですけれども、そうですね、これ一つの KPI に近いものだとは思うんですけれども、どれだけ研究の予算、研究ファンディングの予算が取れているかであったり、あとは IP のライセンス収入がどの程度なのかっていったところを政府側がモニターをしているものです。でこちらで見ていただくと、やはり共同研究ですね、コラボレーションリサーチのところがかなりボリュームがあります。そこで外部資金調達しているっていう構造が見えるかとは思うんですけれども、これも一生懸命今伸ばしているっていったところです。ただですね、2022年見ていただきますと、それをこう分析した右側の円グラフの方ですね、それを見ますと、実はですね300万円以下のブルーが0円でピンクが100万円以下ですね。でグリーンが300万円以下っていう金額規模の共同研究なんですけれども、この3つを足すともう 75% を超えるような共同研究が多いことが分かります。で日本やはり大学、ここから分かるところ、日本の産業界っていうのはですね、大学の研究に対して、投資が進んでいないっていうことがここから見て分かると思います。その結果としてやはり大学の研究成果たる、知財に対するライセンスっていった時に、やはりこういう共同研究のベースの価値観、金額感っていうのが重しになっていて、ライセンスをする時の、レベニューっていうのが伸びないっていうような現状もあります。であとさらに言えば、こういう共同研究っていうのは アウトプットとして共同出願共同発明っていうのが出てきます。でそれがやはり日本の中では、それが多く、またかつそれが社会実装につながっていないっていうような問題点を今日本では抱えており、それをどうするかっていうのが今後の問題になってくるといいますか、課題になっている部分です。で知財に関してはそうですね、棒グラフの上の方にちょっとずつ乗っかっている、あれが IP ライセンスレベニューのトータル金額になっています。ですので、共同研究に比べたらずっと割合は少なくて、大学にとってみたら知財収入の位置づけっていうのは少し希薄になりがちな存在になっています。でこちらは知財収入だけを抜き出して、知財に関するデータだけを抜き出したグラフになっています。左側が、出願の数ですね。出願数としては、外国出願、ドメスティックな国内出願両方合わせてもだいたい1万件ぐらいで推移しているっていうのが状況です。で一方知財収入の方は、そうです2019年からを見ていくと少し伸びているっていうような状況になってます。この少し収入が伸びているという傾向がある中でもやはり出願件数としては横ばい、大学自身も知財に関しての投資が進んでいない、投資をしようとする意識が希薄であるっていうような日本の国の構図が見えます。なんとなく今の話をずっと聞いていると、なんだそれは日本はすごい停滞してるんではないかっていう印象をおそらく受けると思います。で確かに停滞感はあります。その停滞感を解消してくれると期待しているのがやはり、ベンチャーであったりスタートアップっていうようなところに日本は期待感を持っています。でこれは、大学発ベンチャーの、数ですね、数がどのように伸びているかっていったところをここに示しているんですけれども、やはりここ数年っていったところすごく急激に右肩に上がっているっていうような状況です。こう上がってきている背景っていうのはやはり、国自身が政府自身が、このスタートアップ推進っていったところで、大学にお金予算をつけているっていうようなところもありますし、実際に機関投資家、日本の機関投資家がスタートアップに、今投資をしないと、乗り遅れるんじゃないかっていう意識を持ってくれて、投資が進んでいるっていったところもあります。その辺が今後の日本の産学連携の雰囲気を変えてくれたり、これによって、既存の企業さんの、大学に対する、価値バリエーションっていうのを高く意識を持ってもらうっていうようなことにならないかっていうことで私たちは期待をしています。はい、でこんな日本のすごく重苦しい、ある種重苦しい、どっかに光を感じつつも重苦しい雰囲気の中で私たち東京大学 TLO は産学連携を頑張ってます。で私たちとしてもやっぱり産学連携によってより良い社会を作っていきたい、それを、目指して活動してます。ただより良い社会というと少し距離が遠くなってしまうっていうところがあるので、やっぱりアメリカのように具体的にどういうところにインパクトを与えたかっていうそういう数字の方が私たちとしても分かりやすいっていったところがあって、やっぱりアメリカを目指そうみたいなところがあります。はい、そういう視点でいきますと、今東京大学 TLO のアクティビティとして 、少し近づいているというか、そういう見せ方をしながら私たち自分自身もモチベートしていこうというふうに考えています。で今、実際に東京大学の知財を使いながら、プロダクトやサービスになったものっていうのは下の2行目のところに書いてありますね。372件の、製品やサービスが作られているっていうようなところがあります。でさらに、トータルロイヤリティのインカムとしても今は12.5ビリオン円ですね。はい、っていうようなところまで積み上がってきております。まだまだアメリカに比べたら小さな数字ですけれども、地道に頑張っているといったところです。で、会社としてもそうですね、東京大学発、関連ベンチャーっていうのは、2022年度の末時点で今526社できたっていうような統計になっています。そのうち、東京大学の知的財産をベースにしながらスタートアップした会社さんというのが148社っていうような数字になってます。ですのでやはり、私たちの活動によって新しい会社雇用を生み始めてるっていうのを実感しながらこの仕事をしています。でこちらの方は、東京大学単独の特許ですねのライセンス先が、どういうところにライセンスできているかっていったところなんですけれども、57% はスタートアップへのライセンスが行われているっていったところです。残りは43% は既存企業へのライセンスっていったところです。既存企業にもしっかりライセンスは進んではおります。で、ライセンススタートアップにライセンスした技術分野を見ていきますと、やはりライフサイエンスっていうのが 52%、 そのうち 52% を占めていて、次いでナノテクノロジーやマテリアルっていったところがその次に続いているっていうようなところで、やはりライフサイエンスっていったところが少し屋台骨であったり、東京大学の技術の社会実装のメインプレイヤーは今スタートアップであるっていうようなことはこのデータからお分かりになられるかと思います。こうしたそうですね、データを積み上げることができてきている私たちのそのオペレーション自体、オペレーションであったり環境であったり、どういう環境の中で私たちこの技術移転をやっているかっていったところですけれども、東京大学には、私たちも東京大学 TLO は 100% 子会社ではあるんですけれども、100% 子会社の、ベンチャーキャピタルを持っています。それがU東京 IPC と書いてある会社です。でそれ以外にも一部株式を保有している関連するベンチャーキャピタルもあります。それがU東京 H キャピタルといって、U テックと呼んでいるような会社です。IPC はマザーファンドを運営していて、U テックの方は個別具体的なそうですね、スタートアップのサポート、人的サポート、資金的サポートを具体的に行っているっていう、少し住み分けをしながら連携をしております。で東京エリアには、この、東大に関連する、ベンチャーキャピタル以外にも、多くのベンチャーキャピタルが市中にあります。そういうところとも密に連携しながら密に連携はしております。で私たち、東京大学 TLO 自身は、東京大学から技術移転の業務を委託されているわけなんですけれども、委託されている範囲はちょっとこの、緑の中で示しているような、発明のインタビューからもうライセンスまで、全ての技術移転活動の全てのプロセスを委託されています。で私たちの、 プロセスといいますか、私たちの活動の特徴としては、一人のライセンスアソシエイトが一つの発明のインタビューからライセンスまで全て担っているっていうようなやり方をとっています。この、方式といいますか、こういう一人の人間がインタビューからライセンスまで行うことによって発明、そうですね、このプロセスの過程、例えば、いろんなサーチをするであったり、パテントファイリングであったり、あとはマーケティングの過程、ライセンスの過程、いろんな過程でいろんな企業の情報であったり、IP ファームからの情報であったり、いろんな情報がその人に集まってくるっていうようなことがあります。で、そういう情報を次の発明インタビューの時に、研究者に、その情報をフィードバックすることによって研究者自身のその研究の活性化っていうことを促せるというふうに考えています。私たち自身は、そうですね、先生、研究、産学連携をやりながら、技術移転をやりながら、大学の研究の、リバイタライゼーションといいますか、そういう活性化みたいなことも行うことによって、結果としての、スタートアップのクリエーションにつながったり、あとは、既存企業さんへのライセンスにつながったりっていう、そういう、確率が上がるであろうということを、信念に持ちながらこの方式でやっています。はい、でこれは私たちのチームなんですけれども、ライセンスのグループが2グループあります。で、このライセンシンググループ1グループ2グループっていうのが、まさに大学、そうですね、ライセンス先を探索したり、そのカンパニークリエーションのところで、VC と連携したりっていうことを行っている、メンバーです。それ以外にも、一番初めに冒頭にお話ししたように、日本は共同出願、企業との共同出願がすごい膨大な数があります。でそれをハンドリングしているのがリエゾングループになっております。皆さん結構若いメンバーがやってるんですけれども、ここ10年ぐらい大学院や大学卒業した新卒を、育成してライセンスアソシエイトにの育成を行っています。先ほどのすごい多岐にわたるような業務っていうのをやっぱり専門人材として育てたいっていう思いで、今若いメンバーを育てています。はい、で少しビジですけれども、これが私たちが、じゃあ年間どのくらいのなんていうの業務をやってるかっていったところを、ざっくりとここでお示ししてるんですけれども、例えば、年間扱っている発明、インベンションリポートの数っていうのはだいたい550件前後ぐらいをさっきのメンバーで、担当しています。結構ヘビーです。であとは、出願自体も、右上ですね、だいたい国内外合わせて、1200件前後の出願を取り扱っていますし、あと左下が、契約ですね。新たな契約自体は黄色ですごくボリュームがあるのが企業との共同出願ですね。共同出願のコントラクトアグリーメントがどのくらいあるかというと、ここの黄色の大体8割ぐらいが企業との共同出願、2割が、あれですね、他のアカデミアとの共同発明だったりっていうことで、共同出願契約にかなりの業務が割かれているっていう、日本のこれはどこの大学も同じ実態だとは思います。で一方で緑の方は東京大学単独の発明を例えばライセンスしたりオプションライセンスをしたりっていうような数がだいたい110件を上回る程度で毎年推移しているっていうところです。でロイヤリティインカムに関してはやはり、 大学単独の発明の方がやはりこうロイヤリティに与えるインパクトは大きいので、緑のボリュームが大きく示されていると思います。昨年はうちの東大 TLO としてトラックレコードになるような数字で、日本円でいくところの14億円をロイヤリティインカムとして、獲得することができたっていうものです。でこのやっぱりロイヤリティインカムの多くは、企業との共同出願に関しての黄色のところも当然できるだけこう収益につながるようにネゴシエーションしたりしながら頑張っているんですけれども、黄色にしてもこの緑の東大単独発明にしてもやはりライフサイエンス系がこの中の収益の多くを占めているっていうような、現状になっています。はい、で、ここから少し成功事例、これ多分前社長の高もこのデータをよく出していたので、もうご存知の方もいらっしゃるかもしれないですけれども、東京大学の成功事例としてはやっぱりこのペプチドリームっていうものの成功っていうのがあります。で、このペプチドリームは東京大学の菅教授のグループの発明をもとにスタートアップした会社です。で彼らは何を見つけたかっていうとRNA 触媒っていう新しいものを見つけた、それフレキシザイムっていう名前をつけているんですけれども、それを開発しています。でこの RNA 触媒って何かっていうと、普通は天然の20のアミノ酸からしかペプチドって合成できないんですけれども、この触媒を使うことによって天然のアミノ酸以外にもペプチド合成ができるというような技術になっています。はい、で、これを私たちもマーケティングしたんですけれどもライセンスを見つけることができなかったんですね。でそこで少しこう方針転換して、カンパニークリエーションの方でいけないかっていうことで、先ほどの UTEC と連携して、会社を設立してペプチドリームができています。でこのペプチドリームはこの酵素自身を売るのではなくて、酵素を使ってライブラリー、1億個のライブラリーを作って、ペプチドライブラリーを作って、それを売り出すことによってコマーシャライズすることによって、多くの企業との連携に成功して企業としても成功を収めているっていうような事例です。やはりコマーシャライゼーション、どう技術が出てきた時に技術そのものを売るんではなくて、やはりコマーシャライゼーションの大切さっていうのを教えてくれたようなケースです。でもう一つこちらの成功事例に関しては、マイクロバイオームの技術なんですけれども、この当時2010年にマイクロバイオームなんてあまりに最先端すぎて、日本の慎重な企業っていうのはなかなかライセンスをするっていうことができなかったんですけれども、実際アメリカの VC の方がこの論文をこの技術が掲載された論文を見て、大変面白いということでスタートアップにつながったケースです。このようにすごくフレキシブルでイノベーティブなアイデアを持った世界中の VC みたいな方々と出会うことによって、こういう会社の成功っていうのもつながるっていうことを経験しています。はい、でこういう成功事例を通じてやっぱりここに行き着くところがあるなというふうに思うんですけれども、やはり MIT のウィリアム・ウォレット教授がおっしゃっているようなイノベーションdoes not equal invention。イノベーション イコールインベンションタイムズコマーシャライゼーションっていうような、本当にこのコマーシャライゼーションっていうことが本当に大切だということをこういう成功事例からいつも感じております。ですので私たちが技術を見たときにやっぱり技術を見るんではなくて、コマーシャライゼーションっていうようなアイデア思考みたいなものから技術を見ていかなくてはいけないというのを本当につくづく感じながら、これからももう少し、日本のその停滞感を払拭できるような触媒分子になるべく頑張っていきたいなというふうに思っております。はい、最後までご清聴ありがとうございました。
또때도 아리가또 고자이마시다. 여러분 다시 한번 큰 박수 부탁드리겠습니다. 네, 감사합니다. 이 게이코 혼다님께서는 이 동경대 TLO의 이 기술 사업화 현황과 이 미래에 대해서 자세한 사례를 들어서 발표를 해주셨습니다. 다시 한번 발표에 수고해주신 대표이사님께 다시 한번 감사의 말씀 드리겠습니다. 네, 이어서 다음 주제 발표를 이어가겠습니다. 다음 주제 발표는 개방형 혁신 플랫폼을 활용한 산학 협력에 대해서 이라는 주제로 테크니온 공대의 데이비드 쉔 토브님께서 발표를 이어가 주시겠습니다. 여러분 큰 박수로 환영해 주십시오.
Hello, everybody. Thank you so much for inviting me for this interesting event. Very interesting and really people from the community here of TTOs talking about their own universities and about their own initiatives in their countries. So this domain is big. I mean, bridging academia and industry, talking about tech transfer, it is huge. But let's face it, I mean, most of us fail, okay? Most of the universities fail to meet the goals. Most of the big companies, the multinationals, are failing to conduct tech transfer with the universities they work with. Most of the startups fail. Most of us fail. And we are here to share knowledge, to share some best practices, and maybe even to share some failures, because we will learn from failures. And this is the way we see it. My name is David Shemtov. I'm from the Technion, and I will be discussing our experience with tech transfer. Okay. So we are marking 100 years at the Technion this year. It's all started back in 1923, where Professor Albert Einstein from Berlin came to Israel to put a cornerstone for the establishment of the university, and we are marking this year 100 years. We ranked number 79 according to Shanghai ranking. We have 3 Nobel Prizes at the university. Today we are considering to be as the largest applied research center in Israel. We are number 1 in AI in Europe, number 7 in the world as university, with about nearly 150 researchers active in this domain. We have 60 research centers on campus, 600 research teams with about 15,000 students, 19 academic departments, and more than 1,900 companies that were established by our graduates. In terms of working with the industry, with our collaborators, so there are many ways. So we, of course, do research, collaborative research. We work a lot on licensing of technologies to entrepreneurs, to established companies. We put a lot of focus on lifelong learning, because lifelong learning is one of the methods to maintain a dialogue with the industry, maintain a dialogue with engineers, maintain a dialogue with researchers from the industry. And we put great emphasis on that. We have most of the faculties that we have on campus, they have their own innovation clubs, industry clubs, so to speak. So for example, if you will go to the Faculty of Electrical Engineering and Computer Sciences at the Technion, you will find that almost on a weekly basis we are meeting with companies like Intel, like IBM, like Microsoft, like NVIDIA, and a lot of others. trying to exchange practices, to exchange know-how, to discuss, to have a dialogue, a dialogue with the industry. At the end of the day, you need to have a license agreement, but this is just a very technical thing that you would like to have. The main objective is to maintain a dialogue, because without this dialogue, you will not see any collaboration in the future. So this is very important for us to maintain this kind of industry clubs. We, of course, provide also services, and we try as much as we can to enable the research facilities that are on campus for the benefit of the industry. So we are inviting the industry to use our research facilities. Of course, it's not for free, but it is important for us also as a method to maintain this dialogue. This is a list of industrial partners we collaborate with. Just a list. I mean, it could be other lists, but this is just companies that are located very close to us. You will find many of them with a radius of, I would say, 10 kilometers from the campus. So in a way, the campus is kind of a magnet for these kind of multinationals. Some figures in terms of impact. So we have today 134 spin-offs, running spin-offs. All in all, they raised, with a market cap of nearly $20 billion US. 9 of them, they made IPO already. 13 companies with a value of above $100 million. All in all, they raised about 4.6 billion, and they generated 4,600 jobs. And this is also very important for us. This is a portfolio companies of the companies that emerge or grow up from the Technion. And again, we are trying as much as we can to maintain dialogue with them. It is very important for us. So we are all familiar with this TRL scale developed by NASA back in the 80s. Of course, we are in low-level TRL, and this is something which is extremely important, talking about universities, because as was mentioned before by the quotation of the professor from Slovenia, am I right? Slovenia. The researchers, most of them by nature, they don't like to work with the industry. If they would like to work for the industry, they will be probably working in the industry. And they're there because they want to play in the low-level TRL. Now, take also into consideration that if you have a very advanced economy, so you have plenty of jobs out there. Today, in fact, we are facing a situation when we don't have enough PhDs on faculties like electrical engineering, computer science, AI, and decision making, because many of them are in the industry, because the industry offered them very nice jobs with very nice benefits, and it is a problem. This is a problem. But at the end of the day, those scientists that would like to join the university, they would like to play in their own field of low-level TRL. Face it, this is the reality. Now, we need to find those instruments, these tools, this, I would say, a way to encourage them, to motivate them to work with the industry, because still, it is important. It is important. Let me give you a figure. Back in 2022, 2 years ago, with the food tech, when the food tech and alternative protein mainly started to grow in Israel, Israeli startups raised in this year $1.2 billion US. At the same year, I mean, if you will count the money that was available for research in the university in Israel, in the academic world, it was maybe, I don't know, 5%. So 1.2 billion towards, I don't know, $10 million. It is. I mean, and you need to look into this reality, face it, and find the way to work with the industry. Because at the end of the day, most of those startups that raise these gigantic figures, they are still facing scientific problems that they need to solve. And if they will not solve these problems, they will just evaporate, they will disappear. So the idea is to find this kind of very delicate instruments within the university, or to build, I would say, very delicate financial instruments by funding agencies that are tuned with those needs. Now, the problem is that many countries, many of us, try to imitate the winners. So let me put it in this way. We, the Technion, we do well, but we cannot imitate MIT. And if a governmental agency, I don't know, in Slovenia would like to imitate a governmental agency in Germany, it will not work out. Because you need to build these financial instruments that will be tuned with the culture, with the business culture, with the academic culture in each country. And you need also as a university to make these kind of tools by yourself. So I will give you some examples on the way that we see it here at the Technion. So we were discussing this kind of challenge, like, to close the gap, the death valley, what we call in our industry, between academia and industry. So let's take always into consideration that we always have the problem of cultural differences. We will be always fighting about IP, always. And it takes time to sign this kind of agreements, and it takes time to license IP, but this is a big issue. Again, funding resources. You have to find your own resources that will suit your own local needs. Very important. Communication. It is very challenging to communicate between industrialists and researchers. So sometimes, or not sometimes, I would say 95% of my day is devoted to do this kind of translation between industry and academia. Because they live in different spheres. It's a different universe. Risk, talking about risk. We're always talking about risk of companies, that companies put some money into sponsored research or into a collaborative project that takes some money from them and other resources. But there is also a risk in the academia. Professors, they don't like to fail. They like to publish. Again, publish or perish, it is very important. And for them to get into high-level TRL, into TRL, let's say 5, it's a very risky business. Because usually they do research. Maximum they can do a POC in a lab. They are not in the university to develop. Development should take place in another place. And if professors don't know that, we need to tell them that. Almost on a daily basis, do not develop, it's not your business. Okay? So there is risk for both sides, and it is very important when you are trying to negotiate terms, when you're trying to build this kind of bridges, when you're trying to make this kind of dialogue, always take these kind of things into consideration. Very important. We have different goals. The industry is there to make money. We are not to make money. Okay? We can show figures about the money that we make. Very nice figures, very nice slides, but we are not here to make money. We are here to generate know-how, to generate knowledge, to educate engineers, to share the knowledge with the society. This is our mission. And it's always very important to discuss about talent mobility, because at the end of the day, when you make an IP, when you generate IP, and you file it and everything, that's fine. But usually, if you would like to succeed in the tech transfer, you need also to mobilize people. Very tricky business. At the end of the day, let's face it, the reality at the end of the day that startups are the ultimate way to make these kind of things happen. Okay? And usually startups with deep tech, not talking about SMEs, because sometimes you see a lot of figures of universities that generate lots of companies. But companies could be also SMEs that, it's a one-man show or two-man people establishing a consultancy firm. This is not a startup. It could be a startup, but this is not a deep tech startup, because, we need to also to define what are startups. So, and this kind of thing, like, to pack everything in a company, usually with a PhD student from a lab, this is the right way to do it. We believe that this is the right way. I will give you some examples later on. Okay, so I collected some examples from our experience about the way that we work to close this kind, or to build this kind of bridges to close the gap. First example will be EIT Food. So EIT, European Institute for Innovation and Technology. This is a funding agency located in Budapest, in Hungary. They have a budget of 3 billion euro. usually for a duration of 7 years. This was the budget that they had under Horizon 2020 of the European Commission. Now this is the budget that they have also under Horizon Europe. Horizon Europe, it's perhaps the largest, I would say, program worldwide that promotes innovation and research and human capital development, especially with a focus on young researchers. Talking about EIT again, so EIT, they have, I mean, the whole organization sits on 3 pillars. Is to educate for entrepreneurship, is to build innovation projects, and to deal with business creation. Business creation, these are the startups that we are talking about. So everything is focused in a way to close this kind of, to build this bridge between academia and industry on this kind of Death Valley from TRL 4 to TRL 6 that we always discuss. In a way, EIT succeeded in their KPI. Their KPI was just like a funding, I would say a fund of fund. They wanted that each single euro that they were going to put into this play will generate 3 euros, and this is what they achieved. So you can see today that the investment that were made by EIT partners is nearly 10 billion euros. You can see that there are about nearly 2,500 companies, most of them are large companies, that play in this game of EIT, in this what we call knowledge innovation communities. You can see that nearly 10,000 startups were supported by these communities, and there are new services and new products, nearly 2,500. We at the Technion, we participate in 3 communities. Now you have to understand that each community, usually they have like a ticket for 7 years with a check of 400 million euro for 7 years, and usually EIT will extend their mandate for additional 7 years. So about in 2018, I joined a couple of friends in Europe, and we established together EIT Food. I'm one of the founders of this community, and until last year, 10 minutes, okay. And until last year, I was a member of the supervisory board for 8 years. We at the Technion, we joined EIT Food, we joined EIT Health, and we also joined EIT Mobility. So there are 9 communities. Talking about EIT Food, they have 233 industrial members, companies like Givaudan, like Nestle, and like Bosch and Siemens. They supported more than 500 startups. The startups over there raised quite a lot of money. I can remember the first startup that we hosted at the Technion already raised by 350 million euro. But this is the amount of money that you can see in the slide that was invested by the EU in these startups. It was very important for us to educate young people to go for entrepreneurship, because this, at the end of the day, these are the engines for new startups. So nearly 14,000 learners and 427 innovations, where 55 of them are already in the market as new services or new products. EIT generated, I would say, an impact on campus, on our campus at the Technion. About 8 years ago, we built EIT FAN, EIT Food Accelerator Network. So we have an accelerator in Munich, an accelerator in Bilbao, an accelerator in Warsaw, an accelerator in Reading in the UK, and also one at the Technion, and one in Lausanne as well, and one at the Technion. And usually what we do, we host every year 12 startups on campus. Now, this is a different play for university to host startups, like, to open the doors, to let them use research facilities, to let them talk to professors. It's a new play, but we made it, and the impact was, again, very nice. We mentored quite a lot of postgraduate students, and we transfer technologies through this EIT. 24 tech transfer projects were done by the Technion with the funding of EIT and with the partners in the community. So this is an impact, yeah. You can say this is an impact. This is something that really changed the way that we do, changed the way that we live at the campus. Another instrument that I would like to discuss is what we call scientific accelerator or science accelerator. It is a program that was launched 3 years ago by the Ministry of Science, Technology and Space in Israel. And the idea is that 90% of the IP in Israeli universities, at the end of the day, abandoned. Nothing to do with the IP. And I guess this is also similar cases in other countries or other universities. And usually it is abandoned not because it's not unique, but because the researchers develop the IP in a way that they develop research, and usually it's not aligned with the market needs. So what we do with the science accelerator, this is a very, I would say, very modest program, but with a great impact. So it's not a big money. Usually, I mean, we give every research team at the Technion that joined the program $60,000 for 12 months project. With this money, what we do is that we enable them to do a POC in the lab. This is for low-level TRL project. I would say TRL 2 or 3. But the idea is to mentor the group to think commercialization, to mentor the group to think that at the end of the day, it should have a real impact somehow. And what we do is we don't want the professors to become entrepreneurs. No, not at all. I mean, this is not the goal. But first of all, I mean, if you look into the research teams, you will find a lot of PhD students, a lot of master students. Some of them would like to become entrepreneurs, so let's mentor them. But let's mentor them as a team, not as individuals. And this is what we do. We are very, I would say, after 3 years with 3 batches, we are quite happy with the results and also the stage. So you will find today about 10 accelerators in hospitals and other universities in Israel, and I think this is a nice, very nice way with very little money that can have lots of impact. Another, I would say, bridge that we are creating is by really defining the way that we define, or redefining the way that we build a research infrastructure on campus. So at the Technion, we have quite a lot of what we call multidisciplinary research centers. These are, I would say, we are not investing in buildings. We are investing in people, research facilities, and research. Now, if you will talk to me, let's say, 10 years ago, 20 years ago, about the way that we build research centers, so I would say, okay, we build a research center, and the focus is on science, science, science. That's all, only science. But as I said before, when you see today that there are so many resources out there in the industry, and we are today facing huge challenges from the industries to solve problems through science, we believe that we need to change the way that we look into it. So 3 years ago, I took part in the establishment of a research center, and a brand new research center at the Technion, the Sustainable Protein Research Center. And the vision here is to replace basically meat by other alternative meats. So that could be fermented, or it could be plant-based, or it could be cultured meat. And we've done some activities in the past, and we believe that we have a critical mass to go for it. And as you can see, this is the critical mass that I was talking about. We do food processing for many years. 3D bioprinting is also very strong at the Technion. Precise fermentation, tissue engineering, stem cells, computational biology, AI, nutrition. So we believe that we had all the ingredients to build such a center at the Technion, and we convinced the Technion president, okay, let's go for it. But this time when we build the center, we look in another way to build it. Okay, so we are, again, 20 years back, it will be one circle here, science, science, science. Today, it's not that we don't do science and we are running away from science. We still do science, but in a different way. So we put a focus on education and training. Again, it is very important if you want to understand the challenges of the industry, and if you want to really to have an open dialogue, an ongoing dialogue with the industry, just invite the industry. Invite them to see what are the gaps. And so we put a lot of focus on lifelong learning programs, and also here, because the challenges are there. Talking about research and innovation, so again, 20 years back it was only science. Today we want to see what the challenges of the industry are, and to build science accordingly. And also talking about business creation. If I go today in Israel, so in any given time, there will be about, let's say, 10,000 PhDs. Every year, there are about 200 positions in the university, in the academic world in Israel. What about the rest of them, 9,800 PhD students? The idea is to equip them with a set of soft skills to become what we call entrepreneurs or intrapreneurs, because not all of them will establish their companies, but we want to equip them with a set of soft skills that will enable them to make little revolutions in those organizations they're going to join later in the future. So we are talking about entrepreneurial postdoc program. Listen, this is a plan. Not everything is done yet, but this is a plan, and this is something that we work on. Again, entrepreneurial postdoc program. Another thing is that we've put focus on is an acceleration program, because after 3 years with 3 bitches, we find out that it works, and it works pretty well, and it's, again, with very modest money, you can have a great impact. And I think that's all with this plan. Let me show you some things that we've done with alternative protein. So Aleph Farms, it's a company, it's the first company worldwide that have developed a technology to 3D print steaks. This company already raised about $150 million, and they are doing very well. Metaphor is another company that is working on stem cells for cultured meat. This company raised about $10 million. And Axelta is an old spin-off company of the Technion doing stem cells and biotech, and we help them to make a spin-off from the spin-off company that is working now on alternative meat. All in all, you can see here that, we have a long list of KPIs for our Alternative Protein Research Center, and I mark those that are really related, like the way to work with the industry. And again, focus is on lifelong learning with the industry as a tool to maintain a dialogue with the industry. Again, to understand what are the challenges of the industry, but also to work with startups, because let's say most of the scientific challenges will not be set by the large companies. They will be set by the startups. Okay, because if, for example, if I look into this industry, the food industry, so usually those industries spend about maximum 2% of their budget on R&D, while companies like that are active in the field of IT will spend perhaps 40%. So the challenges of the food industry are not set by the big players, they are set by the small players. So talk to the startups, talk to those companies. They will come up with the challenges. Those scientific challenges that need to go back to the lab for lots of work, scientific work, and to come up with solutions or some alternative. And again, talking about a entrepreneurial postdoc program, and I think that I'm done. Thank you so much.
Thank you very much. Your informative presentation. 여러분 다시 한번 큰 박수 부탁드리겠습니다. 네, 감사합니다. 이 데이비드 쉔토브님께서 오늘 1부의 마지막 주제 발표를 해주셨습니다. 다시 한번 감사의 말씀 드리겠습니다. 네, 여러분 이것으로 1부 주제 발표를 마치고 아주 잠시 휴식 시간을 가진 후 저희 다음 세션을 이어가도록 하겠습니다. 다음 2부는 4시 20분에 찾아뵙도록 하겠습니다. 네, 그리고 안내 말씀드리겠습니다. 휴식 후 2부에서는 이 국내 기술 사업화 현황에 대한 발제와 패널 토론을 진행하도록 하겠습니다. 아주 짧지만 여러분 잠시 휴식 시간 가지시고요. 저희 5분 더 쉬도록 하겠습니다. 4시 25분까지 휴식 시간을 갖고 4시 25분에 다음 2부 세션을 진행하도록 하겠습니다. 모든 분들께서는 저희가 휴식 시간이 짧습니다만 2부 세션 전까지 들어와 주시면 대단히 감사드리겠습니다. Now we will take a break time, even though very short moment. The next session will begin at 4:25. Thank you very much. 네, 잠시 안내 말씀드리겠습니다. 저희 곧 다음 세션이 진행되어 오니 모든 참가자 분들께서는 장내로 들어오셔서 착석해 주시면 대단히 감사드리겠습니다. 다시 한번 안내 말씀드리겠습니다. 잠시 후 2부 세션이 시작될 예정이 오니 모든 참가객 분들께서는 행사장 안으로 들어오셔서 착석해 주시면 대단히 감사드리겠습니다. Ladies and gentlemen, the next session will begin shortly, so I kindly ask you to please take your seat. Thank you very much. 네, 여러분 짧은 휴식 시간이었지만 즐거운 휴식 시간과 네트워킹 시간 되셨기를 바라보겠습니다. 네, 그럼 여러분 약속드린 시간이 되었습니다. 그럼 지금부터 본 포럼의 2부 세션을 진행하도록 하겠습니다. 네, 2부의 첫 번째 순서로 우리나라 기술사업화 현황 및 이 발전 방향에 대해서 과학기술정책연구원의 손수정 선임연구원님의 발제가 있겠습니다. 여러분, 연구원님을 무대로 모시겠습니다. 따뜻한 박수로 환영해 주십시오.
안녕하세요. 저는 과학기술정책연구원의 손수정이라고 합니다. 이렇게 만나 뵙게 돼서 반갑습니다. 여러분들께서 더 쓰신 5분은 제가 줄여서 말씀드리면서 여러분들 시간을 지켜드리도록 하겠습니다. 저는 오늘 이 자리에서 한국의 기술 사업화 환경과 비전이라는 주제로 여러분들을 만나 뵙게 됐습니다. 근데 이 주제를 준비하면서 상당히 고민이 많았습니다. 이 자리에 계신 분들이 이미 한국의 기술 사업화의 환경에 대해서는 충분히 이해를 하고 계시기 때문에 저는 과연 오늘 이 자리에서 어떤 얘기를 할 수 있을까라고 생각을 하다가 다소 잘하고 있다, 긍정적이다, 그리고 비전이 밝다라는 관점에서 말씀을 드리도록 하겠습니다. 자, 첫 번째로는 한국의 혁신 성장, 왜 기술 사업화가 필요한가라는 걸로 말씀을 드리고자 합니다. 왜 한국의 기술 사업화가 필요할까요? 라는 주제를 가지고 본다라면 우리에게 아주 적절한 모델을 주어진 분이 계시죠. 여러분들도 알고 계시는 로머입니다. 로머가 얘기하고 있는 경제 성장의 모형, 여기 보시는 것처럼 기술 진보가 경제 성장의 동력이 될 수 있다라는 것을 제가 생각할 때는 가장 명확하게 증명해 준 나라가 아닌가라고 생각을 하고 있습니다. 보시는 바와 같이 한국은 R&D 투입에 관련된 것도 지속적으로 증가하고 있고요. 그리고 기술 R&D 성과로서 확보한 특허에 대한 거래라는 성과도 보시는 것처럼 지속적으로 증가하고 있고요. 그를 통해 창출되는 우리가 최종적으로 기대할 수 있는 경제 성장이라는 측면도 지속적으로 상승하고 있는, 즉 R&D와 특허, 그리고 그것이 다시 제품과 시장, 그것이 다시 성장이라는 연결 곡선을 가장 명확하게 보여주고 있는 나라가 아닌가라고 생각이 듭니다. 그렇게 말씀드리기 위해서 저는 하나 경제 성장의 경험이라는 차원에서 다시 한번 이야기를 드리고 싶습니다. 이것을 가지고 올 때 상당히 망설였습니다. 이 얘기를 하면 내가 너무 꼰대로 보이려나? 이 얘기를 하면 내가 너무 국뽕에 있는 사람처럼 보이려나? 라고 고민을 하다가 그럼에도 불구하고 한국에 있어서는 왜 기술 사업화 그리고 기업의 성장이 중요할 수밖에 없었는가라는 걸 이야기하기 위해서는 이것이 꼭 필요하겠다라는 생각에 이걸 다시 들고 왔습니다. 전 세계 200여 개 나라들 중에 과연 그 나라에 속한 국민들이 자국 브랜드의 자동차를 타고 자국 브랜드의 스마트폰을 사용하고 자국 브랜드의 노트북을 사용하고 자국 브랜드의 가전제품을 사용을 하고 자국 브랜드의 검색 엔진을 사용할 수 있는 나라는 과연 몇 개의 나라나 될까요? 너무나 멋지게 한국은 이걸 해낸 나라이다라고 볼 수가 있다라는 거죠. 그런데 이 얘기를 드리는 이유는 한번 볼까요? 한국의 국토 면적 전 세계 111위. 한국의 인구 규모 전 세계 28위. 아시는 바와 같이 한국의 광물 자원, 에너지 자원 대부분 수입을 하는 나라. 그럼에도 불구하고 한국은 GDP 대비 R&D 투자 규모 2위, 그럼에도 불구하고 한국의 경제 규모는 세계 10위. 이렇게만 보여드리면 사실은 한국이 계속해서 받고 있는 질문, 한국은 왜 기술 사업화를 못해? 한국은 왜 기술 사업화가 안 될까라는 질문은 바꿔 생각하면 어딘가는 조금은 잘못 평가된 게 아닌가라는 측면도 없지 않아 있다라는 말씀을 드리고 싶습니다. 이것이 곧 한국이 왜 기술 사업화를 해야 하고 한국은 왜 기술 사업화를 필요로 하는 나라인가라는 걸 보여주는 가장 분명한 사례가 아닐까라고 생각이 됩니다. 그런데 문제는 이러한 경제 성장이 지속될 수 있을까라는 질문에 대해서는 저 역시 퀘스천이라는 거죠. 여러분들은 어떻게 생각하시는지 모르겠습니다. 한국의 기술 사업화, 그것을 통한 경제 성장은 지속될 수 있을까요? 문제의 시작은 여기서부터 된다라고 보여집니다. 기술은 보다 더 복잡해지고요. 인구는 점점점 감소되고 있고요. 기술 패권에 의해 국가마다 기술 경쟁은 더욱더 심화되고 있고요. 과연 그 사이에 속한 한국이 앞서 말씀드렸던 것처럼 국토의 규모도 작고 인구 규모도 작고 자원도 작은 우리가 계속해서 기술 사업화를 통한 성장을 기대할 수 있을까라는 관점에서 본다라면 저는 그것을 위해서는 연결이라는 키워드를 계속해서 강조해도 지나침이 없다라고 생각을 하고 있습니다. 여기 보시는 것처럼 지식과 자본의 연결, 연구자와 기업인의 연결, 이공학과 법학과 경영학의 연결, 그런 것들이 잘 연결될 수 있을 때 우리는 R&D를 통한 인벤션을 기대할 수 있고 그것을 통한 IP를 기대할 수 있고 IP를 통한 혁신, 그것을 통한 성장을 기대할 수 있는 게 아닌가라고 생각이 되고 있습니다. 그렇기 때문에 누군가가 저에게 대한민국의 기술 사업화에 있어서 가장 지금 현재 풀어야 될 문제는 무엇일까라고 묻는다라면 저는 주저하지 않고 연결이라는 단어를 사용을 할 것입니다. 아마도 오늘 제목에 되어 있는 글로벌 오픈 이노베이션이라는 것도 아마 산업부 키아트가 이런 연결이라는 주제가 한국에 있어서 얼마나 시급하고 얼마나 중요한지를 다시 한번 강조하기 위해서 만든 자리라고 이해를 하고 있습니다. 그러면 한국의 기술 사업화, 누가 한국의 기술 사업화를 이끄는가? 라고 한다라면 분명히 이 자리에 계신 여러분 모두 산학, 연관 그리고 시민사회, OECD에선 이거를 코크리에이션이라고 얘기들 하고 앞서 우리 알린 박사가 말씀해 주신 바에 의하면은 트리플 헬릭스라고도 표현들을 하지만 어쨌든 우리 한국의 기술 사업화를 이끈 각각의 주체의 역할을 한번 보도록 하겠습니다. 우선 산업계는 앞서 제가 말씀드렸던 것처럼 다양한 브랜드를 만들기 위해서 시장을 찾는 도전을 지속해서 해왔다라는 것이죠. 여기 보시는 것처럼 한국의 시장을 찾는 도전은 어쩔 수 없이 대기업을 중심으로 이루어졌다라고 할 수 있을 것이고요. 대기업을 중심으로 글로벌 R&D를 이끌어가고 있고 그리고 산업 인력 확보를 위한 대학과 출연연과 그리고 기업이 서로 협력적인 R&D를 추진하고 있는 것도 대기업의 역할이다라고 볼 수가 있겠습니다. 그리고 중견, 중소, 벤처기업 그리고 중개기업, 아마 이 자리에 많은 중개기업들이 참석하고 계실 것 같은데요. 그러한 기업들이 니치마켓을 발굴하고 내부와 외부의 기술을 활용해서 시장 경쟁력을 확보하기 위한 경쟁을 지금까지 지속해서 해오고 있었던 것이죠. 그러면 앞으로는 어떻게 해야 될까라고 본다라면 앞서 말씀드렸던 것처럼 혁신 환경이라는 것은 그린 이코노미, 데이터 이코노미라고 하면서 전개되면서 보다 더 기술 사업화가 직면하는 환경은 복잡하고 어려워질 수밖에 없다라는 것이죠. 그 안에서 결국은 우리가 직면해야 되는 추가적인 비용이라든가 추가적인 리스크를 낮추기 위해서는 다시 한번 산학, 연관의 연결을 강조할 수밖에 없는 상황이다라고 볼 수가 있겠습니다. 그렇기 때문에 국내 기업들이 국내뿐만 아니라 해외에서도 다양한 파트너를 찾기 위한 노력들을 계속하고 있다라고 볼 수가 있겠습니다. 그럼 학계는 어떤 노력을 해왔을까라고 본다라면 시드를 디자인하는 도전을 계속해서 해왔다라는 것이죠. 여기 보시는 것처럼 학계는 단지 기술을 만들어내는 역할뿐만이 아니라 우수 인재를 양성하는 역할 까지도 해왔고 예비 창업가 과정을 통해서 스스로가 인플로이가 아니라 인플로이어가 되다라는 관점에서 창업가 교육 과정을 지속적으로 해왔고 지금 현재도 많은 대학들이 기업가 정신 과정을 통해서 많은 예비 창업가들을 양성하고 있다라고 보여지고 있습니다. 또 다른 하나의 축이 기술 지주회사라고 볼 수가 있겠죠. 한국은 대학들이 갖고 있는 기술 지주회사 83개의 모델을 통해서 창업기획, 보육, 초기 투자 등을 통한 대학 기술 사업화를 확성화하고 있다라고 볼 수가 있겠습니다. 이렇게 말씀드리면 한국은 뭔가 다 잘하고 있다는 얘기인가? 라고 생각하실 수도 있겠지만 아마도 이 자리에 계신 분들이 저보다 더 한국의 기술 사업화, 대학의 기술 사업화가 직면하고 있는 한계들을 더 정확히 알고 계실 겁니다. 특히 83개의 기술 지주 회사들 중에서 실질적인 수익을 창출하는 회사들이 아직은 10% 내외밖에 안 된다라는 문제의식 때문에 여기 보시는 것처럼 사업화 재원의 규모의 경제 실현, 책임과 권한의 부여, 세대 간 전수를 통한 그리고 실질적인 사업화 실현을 위한 블록버스터급의 무언가의 프로그램을 필요로 하는 시점이 되었다라고 볼 수가 있겠죠. 이것이 어떻게 생각하면 학계가 앞으로 나아가야 되는 기술 사업화 정책의 니즈라고도 볼 수가 있겠습니다. 그럼 영국에는 어떤 역할을 해왔을까라고 본다라면 한국은 대표적으로 출연 연구기관이라는 것이 있습니다. 그리고 출연 연구기관들이 최근에 많은 비난도 받고 질타도 받고 있지만 그럼에도 불구하고 한국이 성장해왔던 7, 80년대, 90년대까지 출연연의 역할을 무시할 수는 없다라는 거죠. 여기 보시는 것처럼 모방에서 추격으로, 추격에서 선도라는 한국 경제 성장의 역사를 함께 한 것이 한국의 출연 연구기관이다라는 것을 우리는 알고 있습니다. 다만 이들이 해야 되는 역할이 이제는 시스템 전반의 실증, 도메인 전반의 실증, 그리고 그 부분이 부족한 것에 대해서 기업의 협력 파트너가 되어주고 기업과 보다 더 다양하고 확장적인 소통을 할 수 있는 역할이 출연 연구기관들에 필요한데 아쉽게도 지금 현재 출연 연구기관들의 구조상 이렇게 다이나믹한 우리가 시장에서 필요로 하는 만큼의 소통과 협력이 이루어지는 체계는 다소 한계는 있습니다. 이건 역시도 시드를 확인하는 도전을 해야 되는 출연 연구기관들 입장에서는 풀어나가야 되는 이슈라고 볼 수가 있겠죠. 자, 이상 말씀드렸던 학계와 출연 연구기관의 사업화를 위한 다양한 도전 중에 최근에 나타나고 있는 대표적인 4가지 성과를 한번 소개해드려 보고 싶습니다. 근데 이 4가지의 성과를 갖고 온 이유는 4개의 모델이 성공적인 성과를 내고 있지만 그 모델이 다 다르기 때문에 한번 가지고 와봤습니다. 첫 번째, 한양대의 경우에는 특허 포트폴리오 이전이라고 되어 있습니다. 신문 지상을 통해서 이미 많은 분들이 알고 계시는 것처럼 LG화학과 2차 전지 소재 하이니켈 양극재 기술을 이전을 했습니다. 그런데 이게 하나의 기술을 이전을 한 게 아니라 산업계에서 필요로 하는 후방 필요로 하는 특허 포트폴리오를 구성을 해서 묶음으로 이전을 하고 많은 기술 이전료를 받아올 수 있고 또 그 해당 랩에 있는 대학원생들이 LG화학으로 취업할 수 있는 연계 효과까지도 일으킨 모델이다라고 보시면 되겠습니다. 또 다른 사례는 세종대 사례입니다. 세종대는 다른 대학들과 달리 표준 특허에 집중을 하고 있는 모델이다라고 보시면 되겠습니다. 2013년부터 표준 특허 전략에 착수를 해서 동영상 코딩 관련 표준 특허 연구를 할 수 있는 교수님들을 확보를 했고 그분들로부터 시작을 해서 표준 특허에 대한 기술을 확인을 하고 지금 현재는 매년 일정액 이상의 기술료를 확보할 수 있는 대학교가 되었다라는 것이죠. 하지만 한국에 있는 주요 대학들 중에서 세종대학교가 R&D 규모가 월등히 높다거나 네임밸류가 월등히 높다라고는 할 수 없습니다. 그럼에도 불구하고 IP 전략을 구체적으로 세우고 표준 시장이라는 곳으로 진입을 해서 지금 현재 우수한 성과를 만들어내고 있는 사례라고 보시면 되겠습니다. 생명연의 경우는 정부 출연 연구기관입니다. 제가 일부러 두 개씩 맞췄습니다. 대학 2개, 출연연 사례 2개를 맞췄는데요. 생명연의 경우에는 산병연 협력 모델이라고 보시면 되겠습니다. 산업계, 병원, 연구소가 기술 개발, 임상, 기술 이전과 사업 수행이라는 모델을 가지고 공동 연구를 해서 실질적으로 최종 단계까지 간 사례라고 보시면 되겠습니다. 그리고 마지막으로 기계연이 최근에 많은 그 하이라이트를 받고 있는 연구기관인데요. 기계연은 실제 이 기술을 필요로 하는 수요 기업과 협력을 했습니다. 글로벌 기업과 실제 이 기술을 필요로 하는 글로벌 대기업과 협력을 했는데요. 여기에서도 한계가 있었어요. 글로벌 기업은 실증 데이터를 요청을 했습니다. 예를 들어 6만 시간 작동을 했는지에 대한 요청을 했지만 우리나라 출연 연구기관이 실질적으로 그 시간을 계속해서 가동을 시키고 실증 데이터를 확보하기는 쉽지 않습니다. 그래서 찾은 경로가 뭐냐면 그 글로벌 대기업의 벤더 기업을 중간 브릿지로 만든 겁니다. 이 글로벌 대기업의 협력 파트너인 중소기업을 우리의 기계연과 협력해서 이 중소기업이 대신 그 실증 데이터를 돌려준 것이죠. 그래서 국내 출연 연구기관, 국내 중소기업, 글로벌 대기업이 하나의 세트가 돼서 한 최종 실증을 완성을 했고 그래서 기술 사업화가 완성이 된 사례라고 보시면 되겠습니다. 이렇게 4가지의 서로 다른 사례를 가지고 온 이유는 기술 사업화의 성공이라는 건 하나의 모델로 합의되는 것도 아니고 하나의 모델로 표준화되는 것도 아니고 각 기관의 특성, 각 기술의 특성에 따라서 상당히 다양한 모델이 구현될 수 있다라는 걸 말씀드리기 위해서 이러한 사례를 가지고 왔습니다. 그러면 정부는 뭐 했냐라는 거죠. 정부는 여러 가지 비판을 받을 수 있습니다. 기술 사업화에 관련돼서 예산도 조금 투자한다, 규제가 많다, 여러 참여가 많다, 평가를 많이 하려고 한다 등등등 여러 가지 비판적 시각이 있을 수는 있지만 그럼에도 불구하고 2000년 기술이전법을 제정한 이후에 전담 조직을, 전문 인력을, 그리고 기술 금융, 정보망, 갭 연결을 위한 다양한 브릿지 사업 등을 수행하는 역할을 해왔다라는 것이죠. 이 외에도 펀드를 조성한다라거나 앞서 우리 홍보 자료에서도 보셨던 것처럼 NTB라던가 TMC, 브릿지 사업 등을 통해서 다양하게 현장에 있는 기업과 현장에 있는 대학들이 연결돼서 사업화를 할 수 있는 인프라를 구축해 주었다라고 볼 수가 있겠습니다. 그럼에도 불구하고 더 바란다면 여기 보시는 것처럼 중심축이 될 수 있는 대형 브랜드가 이제는 필요하다라는 거죠. 짧게 잘라서 100억, 200억 되는 거를 여러 주체들이 나눠 갖는 이런 기술 사업화 지원 사업이 아니라 하나의 거점을 만들어 줄 수 있는 여러 다양한 다주체들이 연결의 구심점이 될 수 있는 대표적인 브랜드 하나를 설계해 주는 그 브랜드는 1000억 사업이 돼도 좋고 2000억 사업이 돼도 좋고 5000억 사업이 돼도 좋다라는 거죠. 이런 사업이 하나 있어서 이 안에서 이것을 중심으로 산학연이 모여서 함께 움직일 수 있는 그런 프로그램이 이제 우리도 필요하다. 정책에 군사를 많이 붙이는 정책이 아니라 이제는 근력을 기울이기 위해서 아주 단단한 구심점을 만드는 시점이 이제는 다소 늦었지만 이제는 됐다라고 생각을 하고 있습니다. 그러면 시민사회는 뭐 하냐라는 거죠. OECD도 그렇고 해외에서 다양하게 시민사회 역할을 강조하고 있는데 우리나라의 시민사회에서 이제까지 어떤 역할을 할 수 있었을까라고 본다라면 기술사업화를 통해서 창출되는 일자리의 수혜자로서의 역할만 할 것이 아니라 이제 그 안에 들어가서 여기 보시는 것처럼 경제사회적 난제를 도대체 기술 사업화가 어떻게 풀어가는가에 대한 모니터링을 할 수 있는 실질적인 주체로서 들어가주는 역할이 필요하다. 그것이 글로벌하게 요구되고 있는 코크리에이션에서의 시민사회의 역할이다라고 보고 있습니다. 시민사회가 절대로 기술사업화의 제3의 방관자가 아니라 그 안에 들어가서 함께 뛰는 플레이어가 돼줘야 될 시점이 됐다라는 거죠. 자, 그러면 앞으로는 우리의 기술 사업화를 위해서 어떤 역할을 필요로 하는가라는 관점에서 저는 글로벌 가치 파이프라인의 3가지를 말씀드리고자 합니다. 앞서 어느 분께서 게임 체인지가 필요하다라고도 말씀을 해주셨지만 저는 그 게임을 3가지로 말씀드리고자 합니다. 첫 번째, 체인 게임입니다. 연결을 확장하는 게임을 하자라는 거죠. 여기 보시면 아래 파란색은 저희 연구팀이 한번 세워본 겁니다. 대학은 한국에 392개, 출연연은 23개, 전문연구원 31개, 국공립연구원 120개, 기술거래기관 176개, 평가기관 34개, 사업화 전문기관 59개, 지원기관 43개, 기타, 특구, 단지 등등등, 그리고 민간 기술사업화 전문 플레이어로서 활동하는 많은 주체들. 한국 속담에 있는 아주 유명한 말이 있죠. 구슬이 서말이라도 깨워야 보물이다. 여기 보시는 것처럼 한국에도 이미 충분히 많은 플레이어들이 활동을 하고 있다라는 거예요. 그래서 제가 궁금했습니다. 그래서 챗 GPT한테 물었습니다. 전 세계에 대학은 몇 개 있어? 라고 했더니 챗 GPT에 의하면 약 27,500개가 있다라고 얘기를 하더라고요. 그럼 전 세계의 정부 연구소는 몇 개 있어? 라고 물었더니 약 8,000개가 있다라고 대답을 하더라고요. 그래서 그래? 그러면 전 세계의 혁신 클러스터는 몇 개 있어? 라고 했더니 이 친구가 이해한 혁신 클러스터가 뭘지는 모르겠지만 제가 분명히 기술 기반이라고 표현을 했더니 여기에 약 500개가 있다라고 얘기를 해주더라고요. 그래서 그 다음 질문을 했습니다. 그럼 VC는 몇 개 있는데? 라고 했더니 약 7,500개가 있대요. 물론 이건 챗 GPT가 얘기한 거기 때문에 제가 디테일하게 확인해 보지는 않았습니다. 하지만 우리가 알 수 있는 한 가지가 있죠. 무엇이죠? 혁신 플레이어들이 너무 많다라는 거예요. 충분히 많다라는 거예요. 무언가를 새로 만들려는 노력보다는 전 세계에 퍼져 있는 이런 다양한 플레이어들을 어떻게 연결해서 우리가 소프트 파워를 만들어 나갈 수 있는가. 이 자리에 오늘 다양한 테크니온에서도 오셨고 스타인바이츠에서도 오셨고 ATTP에서도 오셨고 여러 기관들에서 오셨기 때문에 이 역시 우리가 만들어 나갈 수 있는 연결점이 될 수 있다라는 거죠. 그래서 이제는 우리가 무엇을 만들자라는 것보다 글로벌하게 있는 플레이어들과 우리가 어떻게 연결할까라는 체인 게임을 해보자라는 거고요. 두 번째는 저는 사업화할 때 뭐가 중요해라고 하면 첫 번째도 돈, 두 번째도 돈이라고 얘기를 합니다. 제가 돈을 좋아해서가 아니라 진짜 돈이 중요하기 때문입니다. 왜? 여기 보시는 것처럼 정부와 민간의 역할이라고 하지만 사실은 정부와 민간의 역할을 연결시킬 수 있는 건 역시도 결국은 돈이라는 거죠. 기업이 사업화하는 데 부족한 부분을 어떻게 그랜트로 진입해 줄 수 있는 것인가. 정부가 기업이 초기에 도전해야 되는 시드 구간을 어떻게 정부가 투자 혹은 민간이 투자해 줄 수 있는 것인가 라는 것을 연결할 수 있는 적절한 머니 게임, 그리고 그 머니에는 단순히 그냥 자금, 펀드의 머니뿐만이 아니라 세제, 인센티브 역시도 머니 게임 안에서 같이 논의를 해볼 수 있다라는 관점이고요. 그리고 또 하나 최근에 중요하게 각광받고 있는 크로스보더 VC. 우리가 한국만 VC를 만들자, 한국의 CVC를 만들자의 게임이 아니라 국가와 국가가 같이 결합해서 글로벌하게 투자할 수 있는 크로스보더 VC를 우리가 어떻게 만들어 나갈 수 있는가. 그리고 그 안에서 보시는 것처럼 우리는 국내에 있는 스타트업이나 중소기업들은 어떻게 스스로가 매력적으로 보여서 그들의 돈을 받을 수 있는 것인가. 그리고 글로벌하게 활동하고 있는 해외에 있는 스타트업들을 어떻게 매력적인 기업들을 알아볼 수 있는 것인가 라는 게임이 머니 게임의 틀에서 우리가 관찰해 볼 수 있는 게 아닌가라고 생각이 됩니다. 그리고 나머지 하나는 밸류 게임입니다. 가치를 키우는 게임. 우리가 기술 사업화라고 하면은 대부분은 기업이 성장하고 기업을 통한 수익을 만들어내는 게임에만 국한을 하지만 현실적으로 기후변화라던가 인구 문제라던가 우리가 직면하고 있는 다양한 난제들도 결국은 기술 사업화를 통한 가치 창출에서 그 답을 찾아갈 수 있다. 그렇기 때문에 우리는 기술 사업화도 밸류 게임이라는 차원에서 한번 앵글을 넓혀서 같이 바라보자라는 주제를 이 자리에서 던지면서 5분을 세이브해 드리겠다고 했는데 3분 남았더라고 해서 여기서 이상 마치도록 하겠습니다. 영청해 주셔서 감사합니다. 고맙습니다.
네, 고맙습니다. 이 발표에 수고해 주신 이 과학기술정책연구원의 손수정 선임연구원님께 다시 한번 감사의 말씀을 드리고요. 오늘 이 발제를 통해서 이 한국의 기술 사업화 환경과 비전에 대해서 발제에 수고해 주셨습니다. 다시 한번 감사의 말씀 드리겠습니다. 여러분 다시 한번 큰 박수 부탁드리겠습니다. 네, 감사합니다. 잠시 후 저희가 이어서 패널 토론이 시작될 예정인데요. 잠시 앞서 발제가 중요했기 때문에요. 발제에 대해서 제가 약간 축약을 해보도록 하겠습니다. 연구원님께서는 이 발제를 통해서 이 경제 성장 연결의 지속의 키워드는 이 연결이라는 말씀을 주셨습니다. 그렇기에 이 R&D를 통한 인벤션과 IP 그리고 이 그로 인한 혁신을 가져올 수 있기 때문인데요. 그렇기에 앞으로도 이 대한민국이 경제 성장에 지속적으로 이뤄지기 위해서는 이 산학 연관 등의 연결이 중요하다는 말씀을 강조해 주셨습니다. 또한 이 학계와 연구기관에서는 이 시스템 그리고 도메인 전반을 잇는 이 사업화 모델 설계와 이 실증을 통한 이 소통과 협력 또한 중요하다는 말씀과 이 필요함을 설명 주셨는데요. 아무쪼록 많은 분들께서 많은 인사이트를 얻으셨길 바라보도록 하겠습니다. 또한 이 발제를 통해서 이런 도전은 쉽지 않지만 이 한양대 세종대 그리고 생명연 그리고 기계연이 소통화하면서 이 기술 사업 협력을 통해 어떻게 산업계와 협력할 수 있었는지 그 도전 성과의 예시도 설명을 해 주셨습니다. 그렇기에 이 기술 사업화 환경이 더욱더 발전하기 위해서 많은 분들께서도 앞으로 힘을 실어주시고 많은 인사이트를 얻으셔서 더욱더 도전과 발전 방향이 더욱더 순향할 수 있도록 도와주시면 감사드리겠습니다. 또한 이 마지막으로 이 정부와 민간 역할의 파트너링으로 이 가치를 키워서 이 글로벌적으로도 이 기술 사업화를 연구하고 밸류를 가치를 높일 수 있는 이 예시도 들어주셨습니다. 그렇게 우리 앞으로도 이 기술 사업화 환경과 이 기술 사업화가 대한민국 내뿐만이 아니라 글로벌 전 세계적으로 함께 성장하기 위해서는 여러분들 그리고 민간 학연 등의 이 협력 그리고 이 연결이 중요하다는 말씀 주셨습니다. 다시 한번 감사의 말씀 드리겠습니다. 네, 여러분, 저희 바로 이어서 패널 토론이 이어질 건데요. 이제 거의 패널 토론을 위한 준비가 완료된 것 같습니다. 그럼 앞서 지금 패널 토론은요. 앞서 이 해외 기술화 현황과 이 국내 기술 거래 현장에 대한 발표를 들어보았기에 이 시간 발표 내용을 토대로 이 패널 토론을 진행해 보고자 합니다. 네, 오늘 패널 토론에 함께 참여해 주실 분들께서는 무대 위로 올라와 주시기 바라겠습니다. 네, 여러분 그럼 지금부터 참여자분들을 소개해 드리겠습니다. 큰 박수로 환영해 주십시오. 네, 본 패널 토론은 이 좌장을 맡아주실 서강대학교 문성욱 교수님과 그리고 패널 분들을 소개해 드리도록 하겠습니다. 패널 분께서는 ATTP 의장이신 알윈 웡님, 슈타인바이스 유로파 센터의 CEO이신 닥터 조나단 로에플러님, 다음으로 토다이 티에로의 대표이사이신 닥터 케이코 혼다님, 다음으로 테크니온 공대의 데이비드 쉔 터부님, 그리고 과학기술정책연구원의 손수정 선임연구원님께서 이 패널 토론에 함께 수고해 주시겠습니다. 여러분 다시 한번 큰 박수 부탁드리겠습니다. 네, 오늘 패널 토론은 이 좌장이신 서강대학교 문성욱 교수님께서 진행해 주시겠습니다. 네, 그럼 교수님께 지금부터 마이크를 전달하도록 하겠습니다. 교수님 부탁드리겠습니다.
예, 감사합니다. 저 이 패널 토론의 좌장을 맡게 된 서강대학교 기술경영전문대학원의 문성욱 원장입니다. 저 오늘 그 발표해 주신 모든 연사님들께 먼저 감사드리고요. 오늘 패널을 이렇게 좀 진행하려고 합니다. 제가 지금 아까 말씀 주신 것을 이렇게 정리하다 보니까 그 퀘스천에 대해서 한 4가지 정도 정리가 되는 것 같은데, 하나는 TLO 조직 자체에 대한 얘기가 계속 나오는 것 같고, 두 번째는 이 사이언스를 어떻게 커머셜리제이션 할 건가에 대한 얘기가 흥미가 있었고요. 세 번째는 이제 폴리시에 대한 얘기가 또 안 할 수 없을 것 같고, 마지막으로는 이 글로벌 아까 퍼스펙티브에서 어떻게 연결시킬 것인가, 이게 또 한국의 기술 사업화 랜드스케이프에 미치는 영향은 무엇인지에 대해서 좀 그 4가지 정도에 대해서 토론을 좀 해볼까 합니다. 그래서 먼저 그 방식은 제가 질문을 말씀을 드리고 제가 답변해 주실 분을 이렇게 좀 답변해달라고 부탁을 드리겠습니다. 2분 정도. 그래서 그렇게 해서 2분의 말씀을 듣고 나머지 분들이 이제 애드를 하실 게 있으면 애드 하시는 방식으로 좀 진행을 할까 합니다. 먼저 그 첫 번째 질문과 관련해서 TLO 조직 자체에 대한 얘기인데요. 특히 이 대학의 TLO는 벤처 캐피탈과 많이 다른데, 이 대학의 TLO 조직의 KPI하고 이 직원들에 대한 리워드 방식이 어떤 것이 효과적이고, 그 다음에 어떻게 개선을 해야 될지 먼저 웡 박사님께서 말씀해 주시면 감사하겠습니다.
Okay, I'll try to give it a shot. I mean, TTO and TLOs, they are part of the university function. And if you look into university mission, technology transfer or the application of knowledge has becoming more prevalent around the world. And if I have to quote the gurus, again, one of the very influential person in MIT TLO by the name of Lita Nielsen, is that it is not about money. So, but again, we are accountable for taxpayers' money and university funding and all that. There are KPIs that we have to measure. And usually, those are either numbers or revenues on all the activities that we have talked about. IP patenting, licensing, then collaborative research, contract research, joint ventures with the startups, you name what. And there is actually, of all these lineups of metrics, the interpretation would be very different. In the way that I've explained or tried to illustrate, the entrepreneurial activities in Japan is very low as far as startup is concerned. In China, it's so high. And what is the actual impact at the end? The Europeans are trying to measure that, and started by the UK government, and commissioning their own academics to come up with something called knowledge exchange framework. Is that the ultimate way to go? By measuring the impact of the technology transfer deals that you have done. So there is no one single answer, but I guess we all understand in the top line, the philosophy is actually by creating value that would benefit the society and the economic development. So how do you want to measure that really has a lot to do with the local ecosystem. And I guess I will stop at that because I've already taken too much time in my presentation.
Okay. 감사합니다. 그러면 아까 지금 같은 질문을 우리 혼다 박사님께 여쭤보겠습니다. 그 대학의 TLO 조직의 KPI와 조직에 근무하는 직원들에 대한 리워드와 인센티브를 어떻게 구사하는 게 효과적이라고 생각하시는지에 대해서 여쭤보고 싶습니다.
Just speak. OK. Sorry. そうですね。TLO そのものの職員のインセンティブですね。はい。先ほどそうですね。TLO は VC と違うっていうようなお言葉があったんですけれども、私たち少しなんか最近活動していると。少し VC 的な要素って TLO あるんじゃないかなというふうに思っています。きちんと大学の研究成果ゼロから、ちゃんとこうなんていうんですか一知財を作るで知財っていうのもちゃんと使える知財を作っていくっていう要素のところで、そこからは確かに VC につないでいくっていったところはありますけれども、そこの顕在化するっていうようなところでVC と連携するという意味においては VC 的な要素っていうのもあるんだろうと思ってます。ですのでなんかある種その VC は私が目指しているのは、VC のようなある種こう処遇の、与え方っていうのがTLO の中でもできるといいなと思ってます。すごく大きなヒットをした時にはきちんとしたインセンティブを、そのメンバーに、与えるということによってモチベーションにもなりますし、次の成功っていうのも積極的に作り出そうというようなアクティビティにつながるというふうに思っているので、そういう意味では、TLO も少し要求されるものは VC に近くなってきているように感じてはいます。はい、お答え、質問大丈夫でしょうか。あと何か。
예, 추가 질문 있을 것 같습니다만 계속 말씀하시죠. 예.
はい、はい、そうですね。で、その視点でいくと一つ、課題といいますか、そこの、障害っていうのが、例えば日本の中ですと、大学の職員さんってなかなかインセンティブを付与するようなそういうなんていうんですか、処遇になっていない、この仕事をしたならばサラリーはいくらっていうような仕事の形態になっていて、インセンティブの付与がなかなかしにくい構造になっていると思います。私たちは東京大学からとは分離した子会社、プライベートカンパニーなので、そこのプライベートカンパニーの中では大学のそういうなんて報酬体系に従う必要がないので、私たちはそこのインセンティブっていうものをちゃんと活用しながらメンバーのモチベーション、アクティビティっていうのを上げることができていると思います。日本の中ではやはり東京大学 TLO っていうのは、一定程度成果を出しているっていったところで、こういうモデルになって、やはり大学の組織の中ではなくて大学の外にTLO を作るっていう動きが活発にはなっています。そういう外に出している TLO がまさに今日本の実績を作っているように感じております。
네, 감사합니다. 그러면 다음 연결된 질문인데요. 미스터 토브한테 좀 질문을 좀 드리겠습니다. 테크니온 같은 경우에는 대학 TLO가 포트폴리오 기업들이 어디까지 관여하는지 궁금합니다. 예를 들어서 VC들이 스타트업들을 만들어서 투자를 하고 어떤 스케일업 되는 과정에서 뭐 가버넌스에 참여를 한다든지, 아니면 정기적인 모니터링을 한다든지, 아니면은 마일스톤에 따라서 스톱이냐 고거냐는 거를 이제 이렇게 판단한다든지, 그래서 이제 사업을 접는 경우도 있고, 그런 식으로 이렇게 아주 어그레시브하게 관여를 하는데, 그 테크니온 같은 경우에는 이 포트폴리오 스타트업들이 있으면 어느 정도까지 이 대학에서 이렇게 관여하는지 그게 궁금합니다.
Okay, so let's give some figures, I think, before. First of all, I mean, if you have, let's say, a TTO with 10 employees, and if you have, for example, let's say 200 spin-offs, and if you will have to sit in the board of those companies, you will never be able to generate additional companies. So what we need to have here, first of all, to ask ourselves a question. Do we really add value by sitting on the board? I'm not sure. What about investors? Do you think that you will be able to invest, like to attract more investors if you will be sitting on the board? I'm not sure. So I think these are the first questions that we should ask ourselves. So first of all, the answer would be is it's a question matter of support than of control. So what is the way that we can support a company? So in some cases, you will first of all choose not to be on the board because you think that you don't add any value by sitting on the board. And when you sit on the board, then make a decision to be there because you can add a certain value. So what we do at the Technion, first of all, it's something that also changed the way that we make investments. So if you make investments more in a way of like a safe model that you negotiate terms with the companies or with the spin-offs, not in the early stage of their life, but rather later on, then of course it might reduce the overhead by spending too much time on their boards. And again, the question is more of support. And this is how we see it. And I will give you some examples of the way that we support companies. We discussed before about, in my presentation, about the stem cells, about the cultured meat companies that we generated from the Technion. So our support for those companies and the support to the, I would say, revolution of alternative protein in Israel was more to convince the regulations, the government, to approve new food. So this is a real support. This is a real support, like, to create a lobby that will enable a new regulation. A real support would be, another example would be to attract VCs that will invest in the companies or attract angel investors that will invest in the companies, or to change the regulation internally within the campus that will enable those entrepreneurs to make use of the research facilities or make use of getting an advice from another professor to the team. So I think that these are the questions that we have to ask ourselves, and not to create a certain policy that will be very difficult later on to implement. But again, I mean, when you have a lot of companies, I think first of all, it takes too much time to be there.
그러면은 미스터 토브의 답변을 제가 조금 정리를 하자면, 대학의 TLO하고 VC하고 겹치는 부분이 있지만 또 VC 같이 이렇게 그 어떤 스타트업들을 컨트롤하는 데까지 나가지 않고 서포티브하는 기능에 더 포커스를 맞추고 있다라는 식으로 좀 정리를 해도 될까요?
Yeah, I think this is right. It's more of support than a control. And also when we make decisions to stay on the board, in many cases it will not be people from the TTO. It will be other maybe experienced professor from the Technion or some people that we trust, and we give them the position to be on the board. Again, always for the benefit of the company.
감사합니다. 그러면 같은 질문을 그 혼다 박사님께 여쭤보겠습니다. 그 일본 동경대 TLO 같은 경우에는 아까 포트폴리오 기업들에 대해서 어느 정도까지 관여를 하고 가버넌스나 아니면 모니터링이나 아니면 그 비즈니스의 그 컨티뉴에이션이나 스톱을 어떤 식으로 판단하시는지 말씀을 듣고 싶습니다.
多分今のお話の前提としては、 スタートアップに対して、スピンオフみたいなそういう会社に対してどの程度関わるのかっていう意図としてご質問を受けたという理解してます。既存企業さんですと、私たちが何も関わらなくてもその企業なりの事業戦略とかいろいろなその開発戦略とかそういうのをお持ちでいらっしゃるので、私たちはどちらかというときちんとライセンスをしてそれがちゃんと実行されているかどうかっていうのを、ライセンサーとライセンシーの立場で定期的に情報収集しているっていう程度のモニタリングにとどまるものです。一方でスタートアップに対してはっていうところに関してはやはりスタートアップは従業員も本当に少ない中で、スタートアップしてるっていったところを考えると、例えば知財の専門家が中にいるのかっていうと大体いらっしゃらないことが多い。そういうところで私たちがその知財の手続き的なサポートを一緒にしてあげるっていうこともありますし、私たちマーケティングしていろんな企業とのネットワークがあります。ですので今日の少しご紹介したペプチドリームなんかも初めに連携する企業さんどう当たっていくのかっていった時に TLO が横についていろんな製薬メーカーに当たるっていうようなことをしていました。ですのでそのマーケティング私たちのネットワークを活用してそのベンチャーがいろんな大手の方々と接点を持つっていうところを、促進するようなサポートをしてます。結果的にはいろんな、ベンチャーとの契約の中でいくとそのベンチャーが成功することが、私たちの、ゴールでもあるっていうこともあるので契約したらライセンス契約したら終わりではなくてそこは一定程度スタートアップに関しては、関与しながらちゃんとエクスパンドできるのかみたいなところをできる範囲のサポートをしています。
예, 감사합니다. 자, 그러면 첫 번째 질문을 마치고요. 두 번째 질문으로 넘어가 보도록 하겠습니다. 미스터 토브한테 문의를 드리고 싶은데요. 아까 사이언스와 커머셜리제이션에 대해서 얘기는 사실은 기술 사업화나 기술 이전에 관심이 있으신 분들이라면 항상 깊게 고민하지 않을 수 없는 문제인데 더 나아가서 이제 제가 궁금한 부분은 과연 이 커머셜 석세스 본 사이언티스트들이 다시 리서치 현장으로 돌아올까 하는 그런 의문이 좀 있습니다. 예를 들어서 리서치라는 것, 사이언티스트가 자기 어떤 리서치를 리서치 수준을 올리기 위해서는 상당히 많은 기간을 훈련을 해야 되고 투입을 해야 되고 그다음에 수준을 높이는 그런 누적적인 과정인데 예를 들어서 영 사이언티스트들이 커머셜리제이션을 통해서 어떤 긍정적인 성공을 본 이후에 자기가 하던 그런 아주 브렉스루한 사이언스죠. 그러니까 예를 들어서 아직 어떤 용처를 찾지 못한 사이언스에 다시 돌아올 수 있는지 거기에 대해서 어떤 관찰하신 바나 경험하신 바가 있는지 그게 좀 궁금합니다.
This is a very important question. So first of all, I think that when we are kind of having a dialogue with the researcher, so they are in different phases in their career. And this is very important to ask in what phase the researcher he is or she is in her career. And you need to align the actions or the collaborations that you will be doing with them according to their career. So first of all, if it's a young researcher, say for example, that joined the university 4 or 5 years back and doesn't have a permanent position yet, a tenure, or if they did not receive yet the associate professor, I would say that it is a delicate situation, and I will not encourage them to get it all into establishing companies, because it needs to be aligned with their career. At the same time, lots of young researchers, they would like to establish companies because they would like to expand their own activities. So first of all, you need to be very delicate here. Now, talking about commercialization of technologies from a certain research group, it's also in the way that the university is organized, because universities organize themselves in different ways. So Israeli universities are not like European universities, and European universities are not like American universities. In the size of the research teams and in the career development of each individual researcher. So this is, I would say, first of all, a very tricky question. But you should, if you want the answer, first of all, take into these kind of assumptions into consideration. They are very important. But I would say like this: if let's say that a certain professor approach us and they would like to commercialize or to be engaged in establishment of a spin-off company or a tech transfer, another tech transfer activity, usually, I mean, the idea would be that we will enable such a project to develop that will not kill their career, because you cannot win twice. It takes a lot of time from there to commercialize technologies. Later on, before I was describing the science accelerators that we have on campus, and perhaps the question is also relies in this kind of framework, because the idea is not necessarily to get commitment from the professor, but rather from the team. And if you're successful with the implementation of such approach, then you can have a second time when the professor will establish a company, and even a third chance.
네, 감사합니다. 같은 질문, 아까 지금 이건 이스라엘의 테크니온 유니버시티에 대한 얘기였고, 같은 질문을 우리 그 닥터 로플러한테 질문을 좀 드리고 싶은데, 아까 말씀드린 것처럼 사이언스와 커머셜라이제이션을 위해서 이제 여러 가지 결합시키는 활동을 할 때 리서처들이 자기의 그 리서치 커리어로부터 이탈돼서 오히려 그 리서치의 어떤 발전을, 그 브렉스루 리서치의 발전을 저해할 수 있는 위험에 대해서 어떻게 생각을 하시는지 여쭤보고 싶습니다.
I can talk about our region, Baden-Württemberg, in the south of Germany. Actually, a professor can 1 day per week do what he would like to do, which is not related actually to university. So in these 8 hours, 1 day he has the possibility to work together with company or establish a spin-off or whatever. So this is one way, and it started already 40 years ago about that. That's the way actually Steinbeis network was growing. It gives them the possibility to stay at the university and to work together with a company. And also, if he wants to have a company and quit the university, it's possible, but it's not usual. He can stay in both. And this was a good opportunity for him to test different things, because we heard about the risk. Being a good scientist, you want to publish, but if you work together with a company, there is a risk for the company, but also for the researcher. So it is a framework where you can test different projects with companies. And I think this is a good opportunity, a good example in our region, how you can make the bridge between companies and researcher. Second point, we were talking about technology commercialization, meaning technology push, to bring actually technology to the market. The other aspect which is complementary and for us as important is market pull. Meaning the professors in the network, and it's also the role of our company, is to know actually the demand side. And this is quite difficult, and we heard about translation. I totally agree. 90% of the time we have to translate things, because to understand the demand side, and if I can compare it, the companies are the clients, so they will take the technology, bring it to a product. So you have to understand what is the demand side. And this is not normal for researchers, for scientists. So supporting also this market pull approach through different way, like we are doing it in our region, support actually this bridge and permits to the researchers to stay also researcher. If they want to go further, some of them, they have a company, and we heard about good examples. But I think there is a middle way where it's necessary to test and to have this dialogue and to have the good translation with the company. And third point I would like to add, because we heard about KPI, in our region, what is also important is the percentage of R&D investment. So you know the different scoreboard. You can see in Europe 2.2% of the GDP is invested in R&D. In the region of Baden-Württemberg, it's 5.8, so it's quite high. But most of the part, about 80%, is coming from company. So also we have startups, spin-offs, which are very important. We should not forget the existing company, and not only the large one, but in Germany, in our region, you have machine building, because you have Bosch and all the suppliers. You have the automotive industry and all the suppliers. So the idea of the region was also how we can support the existing company in innovation, in working together with researchers. So this is another aspect in investment in R&D, and to measure this is will they pay actually for the research, for the results or not? And this can be a way of measuring also the impact on the industry. So these 3 points I would like to add to for your question. Yeah.
예, 감사합니다. 약간 지금 그 서로 지역에 따라서 그 사이언스의 커머셜라이제이션에 대해서 이제 접근하는 게 좀 다른 것 같습니다. 요거는 굉장히 좀 섬세한 문제라서 다음 기회에 더 자세히 얘기를 나누는 기회를 갖도록 하고요. 다음 퀘스천으로 질문을 좀 바꿔보겠습니다. 그 닥터 로플러한테 다시 한번 여쭤보겠습니다. 그 아까 얘기하신 특히 유럽이 이제 그런 게 많은데 만약에 이런 그 이 커머셜라이제이션 폴리시가 리지널 레벨에서는 잘 작동을 하는데 내셔널 레벨에서 잘 작동하지 않는 경우가 있고, 그다음에 뭐 예를 들어서 어떤 뭐 클러스터 폴리시라든지 이런 식으로 작동을 하는데 특정 지역에는 좋지만 전체 지역으로는 안 좋다든지, 예를 들어서 아니면은 뭐 지역 간의 경쟁이 일어나서 사실은 어떤 지역이 더 다른 지역보다 더 많은 지원을 받게 되지만 내셔널 레벨에서는 승자와 패자가 나누기 때문에 내셔널 레벨에서는 별 차이가 없게 되는 경우도 있고, 아니면은 이제 지금과 같이 이렇게 그 많은 나라들이 적대적인 관계로 이렇게 다시 리얼라인되는 상황에서 특정 지역이 그 지역에 속한 국가와 적대적인 관계에 있는 국가의 기업으로부터 지원을 받고 있을 때 그걸 어느 정도까지 허용할 것이냐, 이런 식으로 이제 리지널 레벨과 내셔널 레벨에서의 커머셜리제이션 폴리시가 충돌하는 경우가 있는데, 이럴 경우에는 그 유럽이나 그 유로피안 국가들이 어떤 식으로 접근을 하고 해결하는지 궁금합니다.
That's a very difficult question, actually, and it's not an answer for all the different types. I would like to say first, you have Baden-Württemberg, Stuttgart, Porsche, Mercedes, and we're always competing with Bavaria, with Munich, so to see who is the best in R&D investment. Of course, this is something important, and the federal system of Germany is giving some way to solve this conflict of interest. Of course, you have. I'm quite convinced that having at regional level the possibility to decide is a good thing, because each region is different. We had a lot of projects also with East Europe, with Romania, with Hungary, and at that time they could not decide. Also France is very central. So it's difficult from Paris or from Bucharest to know what is the best for a region. And these two levels to communicate, I think in Germany you have one good solution separating the decision-making process. But it's not always working. it's quite difficult. But I'm convinced that having at least a regional level where it can be looking at the demand side, but again, at the regional level, you need to know what is the demand, and it's totally different in Stuttgart than in Hamburg or in Alsace, where I'm coming from in France. So having national policy is important, but then having the flexibility to decide also at regional level is very important. Concerning the investment where a company will go and invest, of course, here you have some competition because some region will give more money if the company is coming than the other. But what I see is the reputation of the university, the different program a university has in collaboration with company is part of the decision. And it's not only about money, we heard about it. Universities are attracting companies. And we see it just as an example because I know Romania quite well because I was doing project with university. Now you have big companies like Renault, which are doing R&D in Romania. They have R&D department. Why? Because they have good engineers, they have good university. And so just as an example, that at regional level, university plays a very important role, or research organization, also Fraunhofer Institutes, and it's attractive for them. So not only the money part, but also the reputation of the R&D network is important, and knowing the demand side.
감사합니다. 그리고 또 그 관련된 정책과 관련된 질문으로 우리 혼다 박사님께 한번 여쭤보고 싶은데, 아까 발표 자료 중에 일본의 특징 중에 기업이 이제 대학에 R&D에 투자를 안 한다라는 말씀을 좀 하셨던 것 같은데, 그 이유가 뭐라고 생각하시는지. 왜냐하면 한국도 유사한 문제가 있어서 R&D 금액은 높지만 기업이 대학에 R&D를 투자하는 액수가 제가 알기로는 줄고 있는 것 같은데, 일본과 좀 비슷한 상황인 것 같습니다. 그래서 혹시 일본의 경우에는 왜 기업들이, 특히 대기업들이 일본의 대학에 이렇게 R&D에 투자를 하지 않는지, 아니면 정책적으로 어떤 그거를 해결하기 위해서 정책적으로 이렇게 뭐 서포트가 있는지, 그게 궁금합니다.
はい、そうですね。これは割と慣習的なところもあってですね、日本はその知識の価値であったり、付加価値みたいなものにお金をつけるという、お金に換算するっていうのがなかなかできない国っていうのが、もうこれは慣習的なものだと思います。で、具体的に例えば共同研究をやるっていう時には、一体なんていうんですか、実費としてどのくらいかかるのかっていうのを積み上げて、でプラスアルファ、大学のオーバーヘッドの部分を載せるだけの共同研究費の考え方っていうのが、これは昔から古くからあるんですね。ですので、例えばゼロって言って本当に先生方の知識を使えばゼロなはずはないと思うんですけど、その知識に対してのお金っていうのをなかなか日本は換算しにくくてつけずに共同研究が走ってしまうっていうようなケースがあります。今そういうところに関しては少しずつ大学自身も変えていこうっていうような、やっぱり大学への期待、その期待に対する価値みたいなところを何らかの金額に換算して、例えば組織と組織、企業と大学っていう一つのラボと一研究所っていうか、企業の 研究機関っていう研究部っていう小さな枠ではなくて、もう少し組織と組織で、大きな付加価値を作っていこうっていうような取り組みを今各大学が始めています。それによって少しこうなんていうんですか、大学で本来あるべき姿、この価値をどう読んでいくかっていったところを今一生懸命そこを、慣習を打ち破って新しいこう仕組みを作ろうとしているっていうようなところですね。はい、少しずつなんていうんですか、日本っていうのはまあそもそもですね、今一生懸命政府は株式投資やりましょうって国民に訴えてるんですね。で日本っていうのはみんなお金を自分のお金をどうするかという、みんな預貯金に貯めて、で物価が上がって金銭の価値が減りますよっていうのを一生懸命国が教えて投資っていうことを慣れようとしています。だからこれが少しずつ若い人からだんだんこう蓄積していくと、もっと日本は投資ができる国に変わっていくんだと思うんですけど、かなりこの慣習を打ち破るのが今苦労しているところだと思います。共同研究費に関してもその辺はその慣習を打ち破るような新しい仕組みを取り組んでいる、取り組んで、変えようとしているっていったところです。
예, 감사합니다. 역시 이 기술 사업화 이전 지식 knowledge transfer 이거는 어떤 그 지식의 자체보다는 자체도 중요하지만 그 사회가 그 지식의 가치를 어떤 식으로 평가하고 그걸 어떤 식으로 이렇게 분배할지에 대한 제도적 관습적 요인이 또 만만치 않게 큰 것 같아서 항상 이 그 knowledge transfer나 테크놀로지 커머셜리제이션 할 때는 항상 어려움을 느끼고 하는데, 역시 지금도 그 지역별로 어떤 식으로 가치를 평가할 것이냐에 대해서 좀 그 어프로치가 차이가 좀 나는 것 같습니다. 그러면 이제 마지막 그 주제로 그 글로벌 퍼스펙티브에서 기술 이전에 대해서 한번 질문을 좀 던져보도록 하겠습니다. 오왕 박사님께 질문을 드리고 싶은데요. 그 여러 글로벌 대학 TLO 간에 그 협력이 가능한 활동이 무엇이라고 생각하고, 그다음에 혹시 실제로 그 글로벌 차원에서 대학 TLO들 간에 협력을 했던 사례가 있으면 소개해 주시면 감사하겠습니다.
Where there's, I guess, because of university, our mandate is to create value for the society. It is actually easier for TLO to work, at least to accommodate each other in spirit. Where it comes to the actual collaboration, you have to look into the stakeholders for their concern. Because if I would very much work with I no longer work for a TTO, but let's say, if a Hong Kong university is very much like to work with a Korean university, you need to work on the specifics. Sign MOU is easy, but getting to get the deal done, you have to think about whether the university owns and has freedom to operate on the intellectual property all by themselves. So if this is co-owned, it is one level of collaborations from collaborative research. If a university has certain IP that can be used by another universities to further develop, that is already licensing. And then you go back to the cross-national considerations. I guess if I would have to break it down to individual cases, it is always a concern of risk and return for the stakeholders. One more layer is the government rules. You're talking about, let's say that the more current ones would be the United States CHIPS Act. Then, for the export kind of stuff, and certain high-tech thing cannot be done. It has always been similar export controls for technology in terms of license, but usually it's being done by the Ministry of Commerce, so you just need to register in that and all that. For China, to expand, for example, for a China-funded, government-funded technology and IP, the first priority has to be licensed to a Chinese company. If you want to get it out somewhere, you have to get the governments or respective ministries no objection, which is normally expected. But in this climate, nobody can tell. So the best way, it is actually for international technology transfer, it is not only at the TLO level. The company, especially the multinational companies, has to come into play. But then when they come in and they put resources into collaborative and contract research, they also would have a very strong influence on how that technology will be licensed or will be commercialized because of their co-ownership or shared ownership in that piece of IP. So ideally, let's say if we can have a Japanese MNC coming out or a German MNC is coming out to coordinate some sort of collaborative research through an agency, let's say Steinbach or Fraunhofer, with Korean universities and Chinese universities. Theoretically, that can be done, and it has been done, but it's a complicated deal. And why people are still doing that? Because at lower TRL, you can only have so much expertise in each university, especially in biotech. So I've seen cases like that on case-by-case basis. On the platform, in the ideology, whereby can TLOs and VCs and governments work together, industries work together to establish some sort of common standard on early stage licensing. And I would encourage people to look into the American model, which is the latest attempt. It is actually in the Columbia University's website. It is called BOLT, BOLT. The stakeholders actually came together to try to work on a standard license for biotech startups, involving the ventures, the VCs, the lawyers, the university, and the government funders. So that has been established. How, to what extent the venture capitals are willing to use that, it is debatable, because that would mean some of the conditions they want to apply to the university startups cannot be done, because they always like to negotiate. But this is at least at one level that I've witnessed that some sort of platform licensed standard agreement has been tried. To a lesser extent and an older generation, and that would be the Lambert industrial agreements by the UK. I'll stop here.
예, 감사합니다. 이 글로벌리제이션과 관련해서 제가 좀 저 패널리스트 분들하고 손수정 박사님께 질문을 다 드리려고 하는데요. 답변은 먼저 미스터 토브부터 미스터 혼다, 닥터 혼다 이렇게 오른쪽으로 진행이 됐으면 좋겠습니다. 그리고 손수정 박사님은 맨 마지막에 저 의견을 말씀해 주시면 좋겠는데, 다름이 아니고 만약에 글로벌 기술 사업화 또는 글로벌 기술 이전에 참여한다고 했을 때 한국 대학이나 또는 한국 기업의 효과적인 엔트리 포인트는 무엇이라고 생각하시는지 궁금하고, 그 이유도 같이 말씀해 주시면 감사하겠습니다. 지금 테크놀로지 트랜스퍼의 글로벌 퍼스펙티브 저에서 이 진행한다고 했을 때 어디서부터 이렇게 하는 게 효과적인지에 대해서 특히 한국 기업과 한국의 대학에 대해 조언해 주시고 싶은 말씀 있으시면 한 말씀씩 해주시면 감사하겠습니다.
Well, I think this is a very complicated matter because first of all, let's have a look into the way that IP is being. Let's have a look first of all into the way that IP is being generated. So, for example, I can tell you that in Israel, we talked before about regulations and the way of the play of the government in this field. So, for example, in Israel, we have what we call the IP law. The IP law of Israel says basically the following: if the government of Israel was the supporter, the financial supporter for the creation of new knowledge, then the IP box should remain in Israel. Of course, you can file it wherever you want to file it, in the US, Korea, Germany, and so on and so forth. But the IP itself should remain in the country, the IP box. I know that we were kind of pioneer in this field, with such a decision, but I know that many countries are following it. At the same time, if you look, for example, into the way that IP is being generated with the support of, let's say, the EU through the Horizon Europe, then we can commercialize it in other places. This is not an issue. But the IP itself, it's a delicate issue, and it is very difficult, or I would say complex, to generate one single model that will suit all. So this is one element that I should think of right now. But when we are talking about sponsored research, I can tell you that only last week I was signing a contract with a Korean company. I cannot mention the name, of course, but with a Korean company that sponsored research for 2 universities in Israel, because the research was so attractive for them, it was so important for them. So we are doing these kind of things, but nevertheless, I would say that if the Korean company, or let's put it in this way, the Korean company was looking into the generation of the IP to see if there are some strings attached, okay? So one should consider it, of course, but this is something that we do on a daily basis. I'm not sure that it is possible to generate a certain, again, suit that will suit all, but this is something doable. And this is something that we do.
Dr. Honda.
はい、グローバル化についてですけれども、今日のスライドの中にもご紹介した日本のバイドール、日本版のバイドールなんですけれども、アメリカですと多分アメリカの発明はまずオリジナルなアメリカのバイドールはおそらくアメリカで生まれたものはまずアメリカの企業にっていうことが義務付けられていると思うんですけれども、日本の日本版バイドールはそういう制限がないっていったところが特徴があります。日本で生まれた知財、日本の政府が研究費ファンディングして生まれた発明が大学に帰属するわけですけれども、その大学に帰属した発明をライセンシーとして日本のライセンシーにライセンスすべきっていうルールはなくて、もうそこの自由なんですね。ですので先ほどのスライドの中でもご紹介したような、例えば海外の VC と連携して海外でスタートアップする、もうそれも日本の中では許される行為になってます。ですので日本の知財は比較的そのグローバルにライセンスを行うっていうことの自由度がとても高いというふうに思っています。でむしろ海外に ライセンスをすることによって、先ほど来からちょっと、日本ってなかなか投資が苦手なんですっていうお話をしているんですけれども、やはり海外に面白い技術が外に行ってしまう、その現場を見て産業界のチェンジマインドができないかなっていったところも、私たちとしてはちょっと危険分子のような動き方はしているんですけれども、そういう日本の産業界の意思決定っていうのをもっと早く流せたり、先端技術に関して、もっと積極的に取り込んでいただくような動きをするために、むしろ私たちは今海外に出ているっていうようなところもあります。いずれもこの海外ではなくて日本の中で産学連携もっと活発にできることを願いつつ、今グローバル化っていうのをやってます。いずれ日本の中で、日本の企業さんにライセンスをして、日本の企業自らがグローバライゼーションというか外に発展エクスパンドしていくっていうのが、理想的だろうというふうには思ってはいるんですけれども、今この過渡期の中では積極的に TLO がグローバル化を仕掛けているっていうようなところです。はい。
감사합니다. The floor, please.
Actually, I will give the example of European research projects which are funded by the European Commission, because here the first point is you need in the consortium, which will develop the new technology, the new services, you have to be complementary through the added value chain. So one important aspect is not having direct competitors in the same consortium, in the same project. If you have it, when you're successful, you get a problem. And it can be through two university or two industry partner, it depends. So having this added value change and the complementarity is, I think, very important as a basis for collaboration. Then when the project is successful after 2 or 3 years, you are still pretty competitive, so because it's funded, so you still need 1 or 2 years to bring it to the market. But then we have a big work of defining the exploitation strategy. Defining what can be published through coming out of this project, because you have 5, 8, 10 partners. So, and in a way, it is a role we have because we are neutral. We don't own any IP as Steinweiss. To see what can be published, what can be commercialized, from which company, or which IP wants a university get. So what I wanted to say with this example is, okay, it's European money, so it's not money from Germany, it's not money from France, it's a common part. And it make it possible to find a way that you commercialize it after 1 or 2 years in different tranches or in different steps. So that I give an example of this Harms and Vendor company in machine building and welding. They were, of course, interested to get the IP concerning artificial intelligence, neural networks, to have the quality control of the system. But this part was important for them. But still, the University of Karlsruhe, which were in the consortium, could publish some part of it which were not tackling the IP of the company. So it's a difficult process, and we should go more in details. But what I wanted to say is, it's not on a global, it's on a European level, but it's a good example of how different university companies from different countries can work together to achieve a product and an impact for European society. Thank you.
Dr. Wang, please.
I actually do not have any generic comments, but on rather the specific front, if there is some sort of I really cannot come out with specific cases because I've seen many of them being successful, but it cannot be introduced as a policy. The best way, I guess, I am no first-hand person who experienced that, but if you want to have a G2G program, let's say, to some extent, EU has been doing that. I've seen the Japanese IP agency, and they are providing funding to African countries to enhance the IP, the management and the use of IP framework. So I guess this is one way that that we have to use government and government-related NGOs and agencies to propagate those. And it is because you have a public mission designed by the government beyond your national policy to get those things done, and you have to get something in the test bed. So I've seen Japanese open up, the IP agency open up training programs, open up a specific funding for university in Egypt. It's public, so I can mention that, to apply for funding with a Japanese university on conducting workshop and technology transfer activities, citing technology transfer success cases. So those are the government-induced activities that is being driven beyond market. Now for market, for my experience, we work with Japanese company on something that, that they really need and can use to conquer the international market. And the difficulties we expect, we anticipate from a Hong Kong university was very much similar to University of Tokyo. It is, our engagement was very first at the collaborative research. And at the end of the day, we were very happy because they're funding it by they're a little bit slow, on the clinical studies and this and that. They were successful. And then we thought, we can apply for patents, and then we can publish, we can license and all that. That the Japanese partner, they said, I'm sorry, I forgot to apply for PCT. But I'm sure it was not the case. But then they had the know-how. We cannot license to anybody else for practical reasons because they co-owned it, right? But to the fact that commercial decision is commercial. So not producing a patent was the best way for them to protect the IP. So, but we are still the leader in that particular license for market worldwide. So I guess it has to go into specifics, and sometimes when it goes to the market and the thing that you designed, I was going to ask, what is the Steinbach's business model for getting all these things to happen? But that is another question for another day. It is very difficult. So sometimes if a country or under certain organizations like APAC or whatever, then you have an agenda to fulfill. Chances are those could be the better venues for you to try something, not at your own cost, but the government would be footing the risk anyway. So, but that is one way to go ahead.
Thank you.
Very difficult questions.
손 박사님, 우리나라 대학이나 기업이 글로벌 퍼스펙티브에서 기술 사업화나 기술 이전 네트워크에 참여를 하려고 하면 어떤 엔트리 포인트가 좋을지 말씀을 해주시면 감사하겠습니다.
네, 처음에 교수님께서 질문을 하셔서 가만히 생각을 해봤는데요. 지금 현재 대한민국은 이번 정부가 주장하고 있는 어떤 글로벌 협력이라는 게 상당히 강조가 되면서 이제는 만나는 부처, 만나는 주체들마다 모두가 다 공통적으로 하는 게 글로벌 협력 얘기를 많이들 하고 있습니다. 그래서 글로벌하게 R&D를 어떻게 협력할 것이고 대상 기관은 누가 될 것이고 그러면서 주요 우리가 알고 있는 유명한 연구기관들이 쭉 리스트업이 되는 거죠. 근데 거기에 제가 다시 한번 묻고 싶은 것이 두 가지가 있습니다. 첫 번째는 묻고 싶은 것이기도 하고 우리가 조심해야 되는 부분이기도 한 것 같습니다. 첫 번째는 제도와 문화 차이에 대한 이해라고 할 수가 있을 것 같습니다. 앞서도 여러분들께서 말씀을 해주셨지만 나라마다 문화의 차이라는 게 분명히 있습니다. 하물며 국가 안에서도 주체 간 문화의 차이라는 게 존재를 한다라는 거죠. 그러다 보니까 우리가 글로벌 R&D를 한다, 글로벌 오픈을 한다라고 했을 때 그 나라가 가지고 있는 기본적인 문화가 어떠한지, 그 나라 연구자들이 가지고 있는 기본적인 인식은 어떠한지에 대한 이해가 반드시 필요하다라고 생각을 하고 있고요. 추가적으로 어떻게 생각하면 더 크리티컬한 이슈가 될 수도 있을 것 같은데 제도의 차이입니다. 무엇보다 중요한 건 IP와 관련된 제도의 차이를 우리가 충분히 이해하고 있느냐라는 거죠. 기존 산업화 시대에서 논의되고 있던 IP 관점에서만 보더라도 제3자 라이센싱을 할 때 공동 IP 소유권자의 동의를 필요로 하는가 필요로 하지 않은가라는 제도의 차이가 벌써 존재를 합니다. 그런데 이젠 디지털 세계로 들어갔을 때 디지털 R&D가 일어나고 디지털 경제라고 했을 때 과연 데이터는 공유가 기본인지 보호가 기본인지, 소프트웨어는 어떻게 할 것인지, 그런 것들에 대한 합의 내지는 이해가 없이 무조건 공동 연구를 한다, 글로벌 협력을 한다라는 접근이 갖고 올 수 있는 그 다음 스텝에서의 리스크를 우리가 어떻게 짊어질 수 있는가, 감당할 수 있는가라는 거에 대한 좀 이해가 필요하지 않은가라고 생각이 되고요. 두 번째 말씀드리고 싶은 거는 우리는 글로벌 협력을 한다, 글로벌 R&D에 참여를 한다라고 하면 좀 무거운 접근을 하는 경향이 있습니다. 아 그래? 그러면 산업부의 현지 거점 만들어야지. 우리 키아트의 현지 거점 만들어야지. 뭔가 현지에 우리의 거점 센터를 하드웨어를 만들고 거기에 우리의 인력을 파견시키고 이렇게 접근을 하다 보니까 기간도 오래 걸리고 비용 부담도 많이 들고 유지하고 관리하는 거에 대한 부담도 또 추가적으로 드는 거죠. 그런데 앞서 말씀드렸던 것처럼 어차피 우리는 지금 알고 있어요. 혁신이 얼마나 빨리 일어나야 되고 다각적으로 일어나야 되는 걸 알고 있다라면 이제 우리가 현지에 직접 우리의 것, 한국의 것을 무언가에 만들어서 진입해야지 이거보다는 앞서 제가 말씀드렸던 것처럼 글로벌하게 많이 있는 혁신 플랫폼들, 혁신 거점들, 혁신 플레이어들과 과연 우리가 어떻게 파트너십을 체결해서 우리가 현지에 나가진 않았지만 우리의 문제의식, 우리의 니즈를 풀어줄 수 있는 어떤 관계 형성이 되는지에 대한 고민이 있다라면 지금보다 더 훨씬 빠르고 가볍게 소프트하게 해외 진출이라던가 글로벌 협력을 바라볼 수 있지 않을까라고 생각을 하고 있습니다. 아마도 정책도 그런 방향으로 조금 더 드라이브가 걸려야 되지 않나 싶습니다.
예, 감사합니다. 지금 논의들을 이렇게 쭉 정리를 해보면 기술 이전, 기술 사업화라고 하는 이 활동은 기술 자체, 과학과 기술 자체만으로 결정되는 게 아니고 그걸 둘러싸고 있는 조직, 그다음에 제도, 그다음에 문화, 그다음에 거기서 발생하는 어떤 그런 그 언서튼티를 다 감안해서 그 리워드와 그 리스크를 어떻게 핸들할 거냐는 거에 따라서 성과가 결정되는 것 같습니다. 그래서 오늘 좋은 말씀 많이 주셨고요. 그 시간이 조금 남았나요? 그 마지막으로 그 플로어에서 퀘스천 하나만 있으시면 받고, 플로어에서 퀘스천이 없으신가요?
혹시라도 질문 있으시면 손 들어주시면
네.
저희가 한 분만
한
질문을
분만
받겠습니다.
예, 플로어에서 퀘스천을 받으시면 있으시면은.
Can I
Yeah,
spend
yeah,
1 minute
sure, yeah.
to talk about one Korean story? And it just come to my mind. It is happening right now. You have a Korean guide who went out to work in Singapore and then moved to Hong Kong. And he is the most successful TTO director, also associate vice president of the Hong Kong University of Science and Technologies. He's not Chinese, does not speak Chinese, and he looked after Hong Kong and the Chinese mainland campuses. and the university presidents like him so much because he worked extra hard. He's Korean, saw that, and he has 100 staff under him. It's the largest in Hong Kong. I guess what I'm trying to say is, if you cannot do it in a hard way, the G2G or whatever, and Dr. Sun was there too, export your people. Train people that are intercultural and willing to work overseas. And it works wonderfully for the Europeans because, like, we still talk about, oh, he's German, he's French, and all that, he's Israel. But at the end of the day, they understand each other. It's not that they have to be each other, but they are. And then I think that would be the best way for Koreans to be successful. I mean, you have so many second-generation Koreans in North America. It's wonderful. I've seen people who are second-generation Koreans working in American DTOs, but they're so American. But then the connection is still to the culture, to the people back home. I think that could be a way to do it.
예, 또 플로우에서나 다른 또 코멘트 없으시면은 예, 이걸로 있으신가요? 한 분? 예, 한 분만 받겠습니다. 예, 예. 그 저 질문하실 분을 호명을 하시고 예, 진행해 주시면 감사하겠습니다.
닥터 혼다상께 질문드리겠습니다. 우리나라 같은 한국 같은 경우에는 기술 이전 사업화가 진행된 지 한 20년이 좀 지났는데요. 초창기에는 일본에 있는 TLO법을 저희가 벤치마크해서 법적이나 제도적으로 도입을 해서 이제 우리나라에 이제 한국의 기술 이전 조직들이 활성화가 됐습니다. 근데 지금 이제 한 20년여가 지난 이후에 지금 몇 가지 차이가 있는데 일본과 한국이요. 전체적인 문제점은 같이 저희도 공유를 하고 있습니다. 아까 말씀하셨던 부분들, 다른 전문가분들 말씀해 주신 분들도 저희가 절절하게 공감하는 부분이 상당히 많고요. 근데 한 가지 차이점에서 제가 정책적으로 좀 궁금한 게 있는데, 오늘날 한국의 대학을 보면 전체 대학 숫자의 4년제 대학의 전체 대학 숫자의 65% 이상이 대학 내에 TLO 조직을 자체적으로 갖고 있어요. 근데 제가 알고 있기로는 일본 같은 경우에는 TLO 조직을 가지려면 승인을 받아야 되는 걸로 알고 있고, 그러다가 보니까 전체 대학 중에 5% 정도만 실제로 갖고 있고 대부분의 대학들이 익스터널 TLO 형태로 운영이 되는 걸로 알고 있거든요. 이게 모르긴 몰라도 이러한 변화가 일어나게 된 데에는 어떠한 그 뭐라 그래 변곡점이라고 그럴까 어떤 계기가 있었을 수도 있을 것 같은데 왜 그런 차이가 생겼다고 생각하시는지 한번 여쭙고 싶습니다.
はい、これもターニングポイントがあったわけではなくて、初めのヒストリーからして外部に大学の外に TLO ができるヒストリーがあるんですね。というのは一番初めにこの TLO 法案を出したのは、メティですね。当時は通産省、今の経済産業省がTLO 法案を主に主導しています。でその時にまず経済産業省が、TLO を作るべきっていうしたのが1998年ですね。で、その後遅れて文部科学省の方が、知財部、大学の知財部を作る。で国立大学法人化した時には内部でちゃんと知財管理ができるようなところが必要なので、知財部を作るっていうような動き、内部の知財部を作るっていうことをしました。で初めに経産省の方で TLO を作っていたので、ほとんどが皆さん TLO は外にあったんですね。経済産業省主導の下で TLO っていうのは独立した機関として作っていたところがほとんどです。で特に当時はまだ国立大学が法人化する前だったので外に作らざるを得なかったんですね。でその後国立大学が日本では法人化したっていうことで中に知財部門ができたんですけれども、じゃあ外にある TLO と中の IP 部門とどうマージするかっていうのが日本の中ではすごく大きな問題でした。うまくマージができたところとうまくマージができなくて少し反発してしまったところ、時には TLO が消滅したところっ っていうような歴史があったんですけれども、結局やっぱり外でアクティブに活動する TLO っていうのが今現状残っているっていうのが実態です。中の、例えば IP 部門とマージしたところというのはさほどやはり実績を作れていないっていったところがあります。それを俯瞰して考えるとやっぱりその一番初めのご質問にあったようなインセンティブの付与であったりなんかそういう問題があるのかなというふうには思います。で結果的にそういうものがうまくワークしているので外部の方が今アクティブだっていうような状況になっています。はい、だから中で初めに作ったところをどう外に出すのかっていう議論とはまたちょっと違う、はい、歴史が日本の中にはありました。はい、はい、回答になってますでしょうか。はい、
감사합니다. 참 이것으로 그 패널 토론을 마치도록 하겠습니다. 감사합니다. 수고하셨습니다.
네, 여러분 패널 토론에 수고해 주신 좌장님과 이 패널 분들께 큰 박수 부탁드리겠습니다. 네, 굉장히 열띤 토론과 질의응답 시간이었습니다. 이 시간이 부족할 정도였는데요. 여러분의 참여와 이 질의응답 대단히 감사합니다. 네, 이상으로 2024 대한민국 기술사업화대전 글로벌 오픈 이노베이션 포럼의 모든 프로그램이 끝이 났습니다. 네, 이 오늘의 논의가 우리나라의 기술 사업화를 더욱더 성공적으로 실현하고 이 발전해 나가는데 뜻깊은 한 걸음이 되었으리라 저도 기대해 보겠습니다. 네, 바쁘신 와중에도 본 행사에 참석하셔서 깊이 있는 논의를 해주신 모든 연사분들과 오늘 귀한 시간 함께 해주신 모든 내빈분들께 진심으로 감사의 말씀을 드립니다. 네, 이상으로 글로벌 오픈 이노베이션 포럼을 모두 마치도록 하겠습니다. 지금까지 진행의 김선우 아나운서였습니다. 함께해 주신 여러분 감사합니다.